Did you do that question 30 with the wall?
Well, I didn't manage to understand how to finish it. I wasn't really sure how to do that one.
Let me go.
2019 question 30, right?
Yeah, like you have like an ant.
Yeah. I didn't think I did. I didn't think I finished that one.
So you'd be interested in going over it.
Yeah.
Maybe as a tribute to your being here, I can go through that problem.
This jumper is very flex. I'm an Italian body with this jumper.
This is the question. You have a wall.
Yeah.
With bricks. How many bricks? 7.5, yeah?
Yeah. I think you can, what's it like you can only walk in the wall tower or something?
Yeah, so 7.5 bricks per row. Yeah. When did you try this one?
Ages ago.
Oh, you never tried it again?
Yeah, I haven't tried it.
Was it in the junior paper?
No, it was in intermediate 2019. I think. Last question. Last year's last question.
Oh, but you never did that paper?
No.
But someone told you about it and you tried it? Oh, okay.
Yeah, I think this is last year's last question for intermediate.
Yeah. Um, 2019 intermediate. Question 30, yeah?
Yeah.
How many rows are there? 15 rows.
Let me see if I have the paper. (2019) intermediate. I think I do have this. Yeah. Anthony the ant is at the top left corner of this brick wall and needs to get to the bottom right corner. Because it is a hot day, he avoids the dark bricks and only walks in the cooler white mortar between the bricks at the top and bottom of the wall. Isn't it the other way around?
Huh?
Isn't like the dark ones the cooler ones?
No. Dark is going to absorb the heat.
Oh yeah. What am I thinking? Never mind. There are 18 rows and 7 whole bricks and 1 half brick.
18 rows.
And 7 whole and 7.5 bricks, essentially.
So it does this, yeah?
Yeah. How many ways are there for the ant to walk to the other side as quickly as possible?
Yeah, only walk along like boundaries. Only walk along boundaries.
Would there be like 18 rows?
Oh, there's 18 rows.
Yeah. So there's no direct path to the bottom. Like there's no direct diagonal zigzag thing. So like you have to go down like at least a few.
Mm-hmm.
Yeah, so you need to go left and 1, 2, 3, 4, 4. Yeah. Okay, so if you go straight down, like right down, right down, right down, right down, you end up at the mortar 4 bricks above the finishing brick.
Mm-hmm. Yeah.
So like, maybe it's like at any intersection you can like go down
Yeah.
and go to the left and go down. Because
Mm-hmm.
go to the right and you're gonna end up if you like instead of going to the left, right? Instead of altering down, like if you alter the pattern and go to the right, you're gonna end up at a brick to like high or something.
Mm-hmm.
And because there's no straight, because there's a wall at the top that you can walk along, but there's no like mortar at the sides, so you cannot just go straight down. So that's the bad thing. You should basically just like get rid of the top half of the thing, not half, top, like most of the top part, top right part.
Yeah. Okay, so let's talk about this question. So it's the 2019 question 30 intermediate, yeah? So you have like a wall with this kind of pattern, 7 bricks on the first row, and a half a brick at the very end. 7.5 bricks. And it's the same number of 7.5 bricks every row all the way down, but it kind of alternates. So it does that. Right? And altogether there's 18 rows. And you can see that because it's even, this side is going to end up the long side, and there's going to be the half a brick on the left side of the bottom. Yeah? Okay. And the rule is like some ant starts here and has to try to get to here. And it's only allowed to walk along the white parts. Well, in the diagram, like the bits between the bricks are colored white. Yeah, it's like cement. Okay, and the question was how many shortest paths are there to get from basically A to B? Yeah. Well, one of the first annoying things about this question was whether the side wall was wide or not, right?
It's not.
And I guess it makes sense that it's not, right? Because
you can just walk straight down. Like you could go down and then just go to like zigzag to the.
Yeah. Yeah, sure. I mean, that's kind of like
that'd be the fastest.
And then it'd be faster than all the other ones, right? So then there'd be like 1 or 2.
Only one, yeah.
Yeah, but another reason why I guess you wouldn't put cement on the side. You're not sticking it to anything.
Yeah, you're not sticking it to anything. That's the point of the mortar.
Yeah. So, yeah. So you can't just go down the sides, and you can't go across the top. Well, you probably could, but you wouldn't want to. You can't go down the bottom here. Yeah. Okay. So actually, the first observation I think is that the you need to go down whenever you can. Yeah. You can't be wasting time going across.
You can't go up or right.
So you should never be going. You should never be going right or left more than once per down. You know.
Yeah.
So you should always be going down. And basically, I mean, if you look at it, the first move is fourth, right? You're going that way. Yeah.
It's a half brick at the top.
It's half a brick here.
Yeah.
That's a whole brick here.
Yeah.
Oh. So it's half a brick here. I should have pointed that out earlier. Okay, so it's a half whole brick, and again it's a whole brick, yeah?
Mm.
And then there'll be a whole brick, a whole brick. Yeah, so the first move is force. You have to go right because you can't go down the side, right?
Yeah.
And you have to go down, otherwise you've wasted your opportunity to go down. You've added this to the path that's unnecessary, yeah?
Yeah.
You have to go down. And you don't actually have a choice here either because you can't go left. Well, it'd be pointless going left because you can't go down. You have to go
At that
right.
point, there's no choice.
You have to go right, yeah?
Mm.
Okay, and then once you get there, you have to go down because we said you need to go down as much as possible.
Yeah, you don't want to go right. Like you don't want to go right twice in a row.
Yeah.
Because then you end up like too far above the right brick, which after point at some point you have to go left, down, left, down, left, down. So basically you've wasted time going right.
Yeah. Okay. And then we're here, right? Down, across, down, across, down. And we still can't go left, yeah?
Wait, you can't.
Is there any? Oh, there's a down here, is it?
Yeah.
Okay, there's a down right here. So now you genuinely have a choice, yeah?
Yeah. There.
You could go left or right. Does that make sense?
Yeah. 1, 2, 3, 4. Oh god, there's so many.
Yeah. So basically, can you see that? Like, you need to go down once, and then you have a choice of left or right. Yeah. But you can't like go left too many times because then you'll hit the side wall, right?
Yeah.
You can't go right too many times, otherwise you hit the right wall. But other than that, basically all you need to do is have the number of rights and lefts add up so it ends up here at the end, right? Actually, you don't even have a choice at the end because you have to finish like this, right?
It's also a half brick at the end.
It's a half brick at the end, yeah. Okay. It's a half brick. Yeah, so at the end, like it has to finish on a right, yeah?
Yeah.
Okay, and to come from the right, it was down just before that, yeah?
Yeah.
And that would have come from this way because it couldn't have come from the side wall, yeah?
Mm.
So basically,
It's like
basically to get to this
13
point.
points where you can like go left.
Yeah, so basically you have to start. You have to end up. This is really the new B, right? And this is really the new A. Does that make sense?
Yeah.
And it's symmetric. Can you see that? 1, 2, 3, 4. 1, 2, 3, 4. Yeah. It's symmetric.
There's only really like four upright up like there's only 4 of these step things that there are to follow down.
Yeah, there's not very many options, right? So one way to really make it really explicit, yeah, is to just write, well, let's represent the rights as +1 and the lefts as -1, yeah? So there's a plus or -1. Yeah. How many of them are there? Well, there's one for each down, right?
Yeah.
So there's 1 and then down 1. So how many downs do you go? So you start on the second row, right? Second row of bricks. you go third row is the first one. And you want to end up on the so you're on the second row, right? Bottom of the second row.
Mm.
Okay, and then you want to be on the top of the. This is the 18th row. This is the 17th row. So you want to be the top of the 17th row or the bottom of the 16th row. Yeah.
Mm.
So you just need a plus 14 to this. 14. 14.
14 rights. 7.5 times 2.
Hold on. This is one, maybe 13. Oh, so you're at the top of the top one. You're at the top of the second one. You're on the top of the third one. You need to get to the top of the 17th one, yeah?
Hmm.
Seems like
Wait, so you can do this algebra then?
Kinda, yeah.
Like a range.
Yeah, so how many times can you go right and how many times do you go down? That's the question, yeah? So you do plus or minus one, yeah?
Oh, you can only go.
Then you go down. Then you do another plus or minus one, then you go down, yeah? How many times do you go down? Is how many plus
From
or
the
minus
very
one?
top,
Yeah, no, from A prime.
A prime until B prime.
Yeah,
Well, since A prime is two bricks down, and B prime is 2 bricks up, so you've lost 4 bricks. So then you just have to travel 14 bricks.
yeah.
But like 14 bricks is equal to 28, right? Because we're just doubling. So 28. Wait, no.
No, it should just
It's
14.
18 rows, so then 18 double. 14 double is 28.
No, you don't need to double it. It's just going down, yeah?
Oh yeah, they have the same down width. Never mind. So just 14 then.
So 14 or 13? 14? Something doesn't feel. Oh, okay, so there's 14 bricks, right? And then you do the plus or minus one. So you do plus or minus one, then you go down. Down. You do that 14 times, and then you do a plus or minus one at the very end, right? So should there be 15 terms here? Does it feel right? 15 terms. Should be 13 terms, I remember.
Wait, try something. I just want to try something and then she'll be back.
One, two, three. So you're sure it's 18 rows of bricks, yeah?
Yeah. Add the question here.
Okay. 3, 4, 5,
I think it's 13 intersections.
6, 7, 8. 10, 11, 12, 13, 14, 15, 16. There seems to be 15 plus or minus ones, yeah? Is that right?
"13 points we can turn left." We go to this one.
Okay, so there's 15 plus or minus ones. It has some rules, right? Like it can't get to. It can get to -1, but it can't get to -2, yeah? It can get to -1, but it can't get to -2. So it's greater than or equal to -1, yeah? And it's less than or equal to. So it can't finish. It can't get to the sidewall, yeah, basically. So if it gets to the sidewall, that's plus 13, right? So it can't get to the side. Can't get to 13. Yeah. And it has to equal. Okay, this is the part that I guess is really telling. If it ends up over here, right? Yeah. Which is 4.5, which is 5.5 bricks away, yeah?
Yeah.
It has to add up to 11. Yeah?
Yeah.
Is that right?
Yeah.
Is it actually 15 terms? I feel like
So from that point, so if we just go down to
one down. So it goes down like 15 times, 14 times.
Yeah, it is 14. Yeah, I'm not sure. Is it?
No, it goes down 14 times, but you
You
add
can
one.
only go left 3 times.
No, listen up. So it goes left or right before he starts going down, and he goes left or right after he finishes going down. Yeah? Okay. And he goes down 14 times, right? So that means there's 15 things. But we might have to check this again. But anyway, okay, so the fact that it has to add to 11 is actually really hard to do, yeah?
But because that's 14 things, right?
Yeah.
And it's adding to 11.
Yeah.
So this 11 times.
There has to be 11 pluses already, right? Okay. Yeah, so there has to be 11 pluses. And actually, there has to be 13 pluses and 2
minuses.
Yeah?
You can only go left twice. That's basically what that's saying.
Yeah. But you can't go left twice at the beginning, yeah? For
That's
example.
from A prime to B prime. You can only go left twice.
So you have to go left exactly twice.
Yeah.
But you can't do it if it means you get to the sidewall. So the only time that actually happens is if it goes left twice at the beginning, right?
Wait, what?
The only time you can't go left twice is at the
Is at the
beginning.
very beginning, yeah, at A
Yeah,
prime.
because of this condition. Yeah. Okay. And the only time you can't go, and you also can't go left twice at the very end. Yeah. That makes sense.
But you can.
If you go left twice at the very end, you would have come from the side wall. Yeah.
Oh, like at the very never mind. Yeah, not at the very end.
Yeah. So you can go left twice. Can't go left twice at the beginning. You can't go left twice at the end. Yeah.
Yeah.
But any other place you can basically go left twice. Yeah. Yeah,
And there's
something-
13 points on the like if you draw a line right down.
Yeah.
It ends up 2 bricks above B prime.
2 bricks above P prime.
B prime.
If you do what?
Right down.
Just 13, yeah?
Yeah.
Yeah. So,
Wait, 13. I mean, from like the very start, right? If you just go right down,
yeah.
it will end up like half brick off the right corner, 2 bricks up above B prime.
Like here?
Yeah, it'll be half a brick off.
Like here? Is that what you mean?
Yeah, something like that.
If you just did 13 right.
Yeah.
Okay. At the
Wait.
beginning?
It won't end up there. It will end up like half a brick off the right. It will end up on that mortar. It will end up with.
The one above it?
No. Down. Straight down. Yeah, there.
Yeah.
If you just trace it down, right down,
Yeah.
it ends up there.
It's up here.
From which you would have to go left down, left down, and then end up there.
Okay, so if you go 13 across, yeah? Is that what you did?
Yeah, if you just go 13 across directly.
Oh, there's something wrong there. That means you can be 13 across. Wait, 13 is 6.5 bricks. Shouldn't that end up on the edge? So when you had A prime, yeah?
Yeah.
Did you go
Right down,
right, yeah?
Yeah.
Down.
And just keep going until you reach just off the
Yeah,
edge.
so if you did 6.5 crosses, you should have gotten to the end, shouldn't you? So maybe you did 12.
12. It's 12. I think.
Yeah.
Yeah, 12.
Oh yeah, no worries. We're waiting on a bunch of people actually. Yeah, so that's 12, yeah?
Yeah.
So it just gets to 12, so it has to go left, yeah?
Yeah.
And then it could either go left or right, and then it cancels it out at the end, right? Yeah. Yeah, so it's kind of weird. So 15 terms, huh? What do you get?
I guess it's only these 3 lines that you can travel across.
Yeah, so I think you came up with a solution that many people came up with. So that would work, yeah? I don't understand why this is 13. 13.
It's 13 because when you get to that point, right? You have to go left, then down, then you have to go right.
Like this point here is 12, yeah?
Yeah, and then when you go left, down, you still have to go right. Or you can just go left. It doesn't really matter.
14, 15. Yeah, you have to go left, and that's the 13th one. Then you go down, and then you go to the 14th one.
Yeah.
And the 15th one's also forced, yeah?
Yeah.
Okay. So you can't have two lefts, and you can't have two rights.
Yeah.
At the very end. So there's two combinations, right? So for some reason this doesn't get the answer that I got last time for some reason. Alright, so does that mean the number of paths is basically the number of ways of picking two minus signs here, right? Minus two combinations of two minus signs at the end and start. So that's like 15 choose 2 minus 2.
What's 15 choose 2? What's the formula?
Oh, it's 15 times 14 on 2. Yeah.
That's 110.
That's 7.
No, it's not.
Don't
I can
cancel.
Two,
Cancel then times, yeah? Cancel then times.
Okay, so 15 times 7.
Yeah. 105.
105. Fifteen times 4, 6. What am I on about?
So this is 103, yeah?
Yeah, 103.
Actually, that's the
I
answer.
think that's the answer, yeah.
That's pretty nice. So basically, actually, there was a bit of a kerfuffle whether it's 103 or 104 sometimes, because you will get 104. Can you see how to prove that it's actually odd?
The number of ways?
Yeah. I mean, you prove the answer, then it's odd. Then it's odd. But like, can you see it another way so that you don't end up with 104?
Okay. So you know how for all the other ones you have two possibilities
Yeah.
of either like going right or left at
Yeah.
any point.
Yeah.
Right? But if you look at that case, right down, there's only one way for you to travel to B prime. And so because there's only one way, and while everything else there's like a multiple of two ways. So then then it must be odd.
Yeah, that could work. Alright, check this out, okay? So basically, you know how there's two minuses at the beginning that can't work? There's two minuses at the end that doesn't work? There's actually a complete symmetry from beginning to end. Does that make sense? Like, if you just rotated B to A, you'd be going from B prime to A prime. It has the same number of paths, right?
Yeah.
What that corresponds to here is reflecting all the plus and minus signs about the middle, yeah? So if you do that, right, then the ones that are different when you reflect it are even, right? They pair up. But the ones that are fixed, right, you just have to count them to see if it's odd or even, right? Does that make sense? Like, for example, can you see how many fixed things there are under this transformation?
How many
fixed? Like if I switched, so if I took a term, right, and I have +1, -1, +1, you know what I'm saying? And
like going left is +1 and going right is -1, right?
Yeah, and the middle thing is like +1, right?
+1, yeah, inverse.
And then I have like, -1.
Oh wait, is it because it's 15 times, so the middle one will be like +1 no matter which direction you're going from?
Well, the middle one could be -1, right?
Like so you like have a middle term,
Yeah.
so like everything else is in like symmetry.
Yeah.
The middle term remains constant.
Yeah. So for example, like the reflection preserves the middle term, right?
Yeah, that's what I was kind of.
So if the middle term's a minus, yeah, then the other minus is going to move to the other side. So it's going to be not fixed, yeah? So you need the middle term to be a plus, and you need the two minuses to be symmetric, right? Does that make sense? So the two minuses could be at the very ends, yeah? Or it could be the second one from the ends. Or it could be the third one, right? All the way up to the 7th, yeah? there's 7 terms which are fixed. Yeah.
Yeah.
So those 7 terms which are fixed, there's an odd number of those. Yeah. So you know the answer has to be odd. That makes sense?
Yeah.
Because all the others are even.
Even and then just
The others are paired. Yeah.
except
there's
for
a-
the middle one, which is
Yeah. Yeah. So, and actually, I think if you have an idea, like, so not all the, like, even if you don't get it completely, it's not completely wasted, because if you can kind of have an idea, you can really narrow the possibilities down to like if you can narrow it to 100 something.
Yeah, I think this also ends up in the 15 choose 2 minus 2 thing.
It's exactly the same
Yeah, it's the
approach.
same
So
thing,
you have to
yeah.
actually realize it's the same.
Yeah.
So most of my time explaining this is just to explain it's the same as
Same
the
thing.
one you're thinking of.
Yeah.
Except this one is kind of maths.
Mathy, and this
E,
is
yeah, like because I use ones and pluses and minuses, and you just use a path, yeah. And I guess this is sort of more readily convertible into other problems.
yeah. This one you can generalize. This one
Yeah, it's pretty much the same, and so and then for you, it's going the paths from B to A. That's what this flip corresponds to, yeah.
shut me back. Oh, great. It's good. They even squeak more. It's cold. Super strict.
Yeah.
It basically is covering my entire body.
Okay, let's do something.
Now it's covering my entire body. It's not sufficient.
Yeah, so this other one is from NZ MO question 1. And most of you can get this. I just kind of want to summarize this again because it relates to floor functions a little bit. So basically the question asks you to find nu2 of 50 factorial. Yeah. So this notation is just like the highest power of 2. For which, like highest power k, for which 2 to the k divides 50 factorial. Yeah? Okay. So actually, I could also do this in the class tomorrow as well, but actually, I don't even know who's coming to any of these classes anymore. So 50, so this basically is actually a pretty nice formula, right? Because, the first level is to count all the even numbers, yeah? And how many even numbers are there? Well, it's 50 on 2, the floor of 50 on 2, yeah? Just in case it was 51, yeah? Okay. But then, the second level is to realize that the multiple of 4s need to be counted again.
Or powers.
So when you have, like...
Oh, yeah. Multiples of 4 is something times the power of 2.
Yeah, see?
Yeah.
You got to add those back. And you don't have to add 2 because you already counted 1 here, right? But then you're like, oh, am I done? No, wait, there's powers of 8. There's 8s. there's multiples of 8s in there, right? Yeah. And yeah, so the floor means the integer, just the greatest integer that's less than this. Yeah. So if it's already an integer, then the floor does nothing. So for example, this is just 25.
25.
This is not an integer,
12.
right? This is 12 and a half, yeah? So this will
floor's
go round down to 12.
6.
And this will be 6.
Next one's 3.
So 50 on 16 is 3.
32 is 1.
And then plus 50 on 32. And we stop going because we run out of
Yeah, the next one will be 64, which is about 50.
0, yeah? And that'll get you the answer, yeah?
7.
Yeah. So in general, you know, if you have like a v of a prime of n factorial, we have that this is equal to n on p plus n on p squared, yes?
Yeah.
N on p cubed plus forever, yeah? Because it'll be 0 eventually. Another way to write that is the sum of k from 1 to infinity n on p to the k, right? And it's not worried that there's infinite many terms because it'll be 0.
Yeah.
At some point. Yeah. So this is the kind of thing where like you can definitely figure it out without the formula, but if time is scarce, it could pay to know the formula. You don't have to figure it out again.
Plug it in.
Yeah.
Wait. Does the calculator work with that?
With what?
How would you plug in the calculator?
Oh, you need the numbers.
Yeah.
Yeah, you wouldn't even have a calculator in your exam anyway. So, so plug it into your brain. How do you plug it into your brain?
Brain work that.
Yeah. So yeah. I'm actually really hungry. Oh my gosh. Okay, so I'm gonna leave this question up on the board. If people don't know what functions are, we can explain it.
Who's watching the stream today?
It's Sean and Orlando.
Is the line with you?
Yeah. He's also in year 9. But he's from another school. Okay.
Another kid may come
Who?
from Riffs.
Really?
Yeah. From the class. Jeffrey may come.
Oh. Interesting.
Got a prize last year.
In
AMC.
AMC. Fine. Oh.
Yeah, really.
Open functions.
I think I forgot that. Where's my paper? Huh. Misplaced. Never mind.
I'm so hungry.
Relatable. Oh,
Are you hungry too?
yeah. Wait, why do you have a coyote? You know the snake Pokemon one? You know the snake Pokemon? He has a secret. Also the snake Pokemon, the snake Pokemon has a secret. So when you read his name backwards, it says snake. And he's snake. You have 2 Mewtwo's? 2 shiny Mewtwo's. We have a lot. Shiny? I need a favorite way of Pokemon. No, Growl. What? Rayquaza, Darkrai. I got this Pokemon. Wait, what Pokemon is this? That was Lego Mewtwo. Oh, that's a Mewtwo with like one of the Mewtwo. My grandpa got it too. We got it from a friend. I got that Mewtwo. Purity, Cactus, you know, Cactus, Steelix, so many good.
Oh, you think Steelix?
Maybe cold.
Maybe cold.
Yeah.
You
want to see my buddy? I got that because I was not concentrating and I got a shiny small Pokemon. That's a legend. That's a legend. I No, you have 700. Yeah, 500.
you have multiples, yeah, 3 meters. Sell them. I'm not challenging one. I was not challenging.
I'm just telling you I'm I don't know, but it's not very my face is halfway out together. But when I'm done my homework, I will be at the
How many should we go?
I don't know, but oh my sister's playing Clash Royale right now. You want to see? What is not interesting. But the Clash Royale is a girls' fun game. So yeah, it's interesting. Clash Royale is interesting for you. And now, both are not interesting for you. It's a type of game. Might be the same, different way. Don't know. Let's go to battle. Now my sister's playing a fight. Oh, you're making me You're making me fight already. No. Let's play Clash Royale. And what should we play? How am I waiting for you? I mean, then,
Right, Kavan, Sidro's on the stream. Sidro's on the stream.
Yeah, he is. Yeah. He said he's not coming. He's going to be on the stream then.
so this was
Yay.
I'm making my
want ginger?
Yeah.
Ai, 没有蛋，我比这个蛋给你了。等我太着急了，我没来。
Oh no, I'm done for. I'm screwed. I'm super screwed. Yeah.
So funny. That pizza's on the toilet. So funny. Pizza on the toilet. The pizza in the toilet. Well, Mama,
And solve this.
That one? No.
Hey, welcome. Have a seat.
Hello, Teddy.
So, how much functions do I have to explain to you? Can you do this one?
I've done functions before. Just did inverse functions at school today. Not fun
Yeah.
because problem with this in school inverse functions is that you can't afford to do things rigorously. Yet you're scared if you don't do them rigorously. It's like this dilemma. If you do it totally rigorously, you don't have enough time.
Yeah. It's like you're afraid that they won't understand it, even if it's right.
Yeah.
But then you're afraid it's wrong. We're in.
Yeah. Just, why not? That's the problem with school now. It's just... Is anyone else here?
There's like a couple of people in the stream.
Oh, okay. I want to do AMO because we're doing AMO. I think this Thursday.
Hey, Mo.
Yeah. No, I mean
ANC.
ANC. Sorry.
The letters matter a lot.
That's what I'm because all I'm thinking about is the AMO. Because that's what actually matters.
Okay.
Yeah.
Oops.
Is this like a standard function question or is it a really hard one?
It's kind of like it's standard looking, and I think it's not really hard. I'll have to explain. It's basically actually depends on how you measure hard, right? If you measure hard in like the number of steps it takes to show the answer, then this is not hard.
Oh yeah, but if you measure hard by like
The time it takes to see that step.
no, like, yeah, like well, if you measure it by the number of steps, then the school math is the hardest. School math is the hardest. It takes like 20 steps for some questions.
What? Why?
It's because it just does.
Alright,
It's usually some like ridiculous solution.
so we're a little bit out of order because of the schedule, but it's alright. I think it worked out just fine. So I want to basically introduce functions, yeah, and functional equations, okay?
Yeah.
And basically, you can close the door. Come on.
Has Command done them before?
Yeah.
Oh, good.
So I'm not going to spend too long. I'm mainly going to emphasize the difference between the school functions and the.
Yeah,
That's a
they're
good
basically two different things. It's like apples to oranges.
So what a function is essentially. So the definition of a function is you have two sets. So like a set X and a set Y, and that's called the domain. And this is called the codomain, okay? And usually the function is just considered the rule even. Sometimes you forget about the domain and the codomain. But the proper definition is it's three pieces of data: the domain, the codomain, and the rule, okay? And what it needs to do for it to be a function is that for everything in the domain, the rule has to assign something in the codomain, okay? And that something is determined entirely by the thing which it came from, okay? It can't just suddenly change if you decide to look back at it or something, yeah? So if this element of the domain is fixed and the rule is fixed, then the element of the codomain is fixed, and it's called, f of x, if x is in x, okay? So
Does that have to be numbers?
it doesn't have to be numbers. So that's the thing that's already interesting. But without loss of generality, you can assume they're numbers.
Yeah, just like
Because numbers can be identified with everything, basically. Like if you think of them as cars, you could just think of the cars as their
because
numberings.
real numbers can identify.
Yeah. So actually, that's a good question. In general, you don't lose that much information by changing any set to numbers, Because as far as sets are concerned, it's really just how many there are, okay? And that's sort of where it starts to differ from school functions, okay? So school functions never even talks about the codomain, okay?
Let's talk about the range.
And it doesn't talk about the domain when it's meant to be defined, right? It actually it's a question what the domain is.
Because we assume it's real numbers. Like
Yeah, so basically what the question that they ask, what is the domain of f, right? So they give you the rule first. So what they really mean is, well, what is the natural domain of f? So it's like, what is the biggest subset of the real numbers for which this formula works? Yeah, that's what they mean.
Yeah, that's what they mean by find the domain of f.
Yeah.
Like,
So that's why sometimes the rule kind of tells you what's going on. Like if you have the rule, you can kind of figure out a domain for it and a codomain for it. And so, but in school, so in school you just have range, right?
Yeah.
So codomain is something that's bigger than the range or equal to the range. So the point of having a codomain is it's easy to define it at the beginning to say like it outputs real numbers, right? Because you might not know what it outputs because you don't know anything about the function at that
Oh,
point.
so now I know the difference between codomain and range. The codomain is something you set like for every function of this type. You can
Codomain is sort of like a prelim thing to have a set that catches the outputs. And then when you understand more about the rule, then you can replace it by its range. Then you know like a tight set of outputs. Yeah.
So you say all functions f of f from R to R with the real numbers of the codomain. But for example, the function may only output. You might find out that function only outputs positive numbers.
Yeah, exactly. And then you can restrict the codomain to the positive numbers. Yeah. Yeah, so in that sense, the rule is sort of the most important thing, not necessarily the sets, right? But sometimes it's important to fix the sets to know what you're actually talking about.
Sometimes they're like, sometimes school just omits the sets.
Okay. And so one of the very special things about the real numbers, yeah, is the continuum property, okay? They're actually completely continuous line of real numbers, which is kind of crazy. So in school, the functions are essentially dealt with as continuous things. So you always have kind of, it's implicit that the functions are continuous and their graphs are always nice, right? So the difference in Math Olympiad is essentially the focus on the discrete aspect of the functions, yeah? So it's like a discrete maths thing. So it doesn't necessarily care about the real numbers being continued, right? It's more just about that there's large real numbers, there's small real numbers. You're kind of just subbing them in one at a time, if that makes sense. The sort of the continuum property isn't necessarily part of this discussion, yeah? Then a lot of the times you have integers, and that emphasize the discreteness. Okay, so this is sort of the discrete maths version of functions, which is kind of like, where it really starts. There's like finite sets. Finite is meant to be the easier one to deal with. And then it got crazy when people started doing analysis with real functions. Okay, but the Maths Olympiad part focuses on the discrete part of the functions. Okay, so for example, most of the time, even if it's for real numbers, all you have to do is, it's like algebraic. You sub in values. It has its inverses. It has negatives. You don't necessarily know that you can like get in within intervals or do many inequalities until it gets harder. So that comes later, yeah. But at the start, it's focused on discrete because that's a natural place to start because it's finite and it's easy. And then when it gets to the continuous, it's actually really hard. Whereas in school, it starts with the continuous and they don't justify anything, so it's kind of easy just by default.
Oh yeah, because it's intuitive.
Yeah, but you can actually go quite wrong. So, and that's kind of the history of analysis. Okay, I hope that explains some things. Does that make sense?
You
So-
can't afford to be rigorous.
Yeah, and a function, the idea of function, it underlines essentially the foundations of mathematics. Okay, but these days in modern maths, I think it may be a bit lacking at the moment. So it's not quite the whole story, And then you'll learn about sort of functors and categories instead of sets and stuff like that. Okay, which captures a bit more of what's going on, and then sort of functional equations. Okay, so this is an example of a functional equation. Okay, a lot of the time it'll involve some kind of Oh, I should also say functions have a natural operation that's not explicitly considered too often. So when you have a function from x to y, right, and another function from y to z, there's a natural operation that combines them into a function,
Circle.
the composition of f with g. So sometimes this is backwards, but you first do f, then you do g, right?
And I think we've done this before.
Yeah, and this is the natural way to compose, to operate on functions, and you need to do this because this is what the chain rule is, right? In school, the chain rule tells you the derivative of this composition. It's the product. It's the product of the derivatives of the two functions. Yeah. Okay. So basically, and a functional equation, it's usually like an equation, right? And the things in the equation are usually compositions and kind of algebraic operations on functions and variables. Yeah. So here you have like f of x plus f of y, right? And then here it's like 2 times x, so that's like a just like a scaling thing, and then it's 2 times f of y plus 1. Yeah. Okay, so here it's like a functional equation, 2 variables. And basically, you're trying to find out what the possible f's can be, right? Trying to find all possible functions with fixed domain and codomain satisfying the equation, right?
Interesting is, wait, is the cardinality of the number of possible functions greater than the sets themselves?
On the sets,
Yeah.
yes.
So even for infinite sets.
Yeah, so there's a theorem that says, or there's an axiom that says, for a set, okay, the set of all subsets of that set is called the power set, is always a set, okay? And then there's a theorem that says that set always has a greater cardinality than
The set itself.
the set itself, yeah? And you can see that the number of functions essentially is more of those in the power set, because for every subset you can think of a function as, you know, including that subset inside or something, you know? Like a function can just be defined on that subset and sends it inside, and then maybe it's 0 on everything else, for example. So there's at least as many functions as power sets, subsets of the set, and the number of subsets is of a greater cardinality than the set itself. Okay, and that, I guess that'll make more sense when we do more about cardinality.
Yeah. And like
But that's more just for like understanding, deeper understanding.
the function.
Yeah. So for problem solving here, it's just find all the possible functions satisfying this equation. So basically, what is this equation really? It's kind of like, it's basically like an equation in 3 variables, right? Where you have kind of control over like the x and the y, but you don't have control over the f.
And you
Yeah.
solve for f.
And you're trying to discover about the f. Yeah.
Mm.
And actually, a lot of the things that make this functional equation look complicated is actually something that makes it easy, okay,
Yeah.
in some sense. Like, for example, having like an x and a y, like 2 variables here, right, usually makes equations harder
But
because
in
it's
this
harder.
case,
But
it
when
makes
it's a
it
functional equation, because they're the things on your side, right, it actually makes it easier
The numbers, the variables are on your side because
because you have control over them. Okay. Another thing that happens is, so maybe like sort of the most generic way of looking at this, right, is you basically have sort of one equation for every pair of variables x and y. Yeah.
yes.
So you have just a ton of equations, okay, but you're also trying to find a ton of unknowns. Yeah.
Yeah.
So basically, the unknown you're trying to find is f of z for each z, you know, for each real z. So for every real number z, there's this number f of z, right, that you need to find. So basically, you have sort of, you want to find the value of a real number of variables, right? and you have at your disposal conditions that will help you do that, and you have like one equation for every pair of x and y. Yeah.
So you have like an infinite amount of
Yeah.
equations.
So you have like
Infinite
a plane full of equations, and you have a line full of unknowns you're trying to find.
Yeah.
Yeah. I'm actually making this sound a lot harder than it is. It's not very hard at all. But this is generally what it is. Yeah. And so in principle, so this doesn't actually come up that often in practice, but in principle, you can have the same results in like that you normally would expect with equations, right? So if you don't have enough equations to determine the unknowns, then you'll just have a ton of possible solutions, right? If you have a lot of equations, you can definitely don't have many solutions, right? Or you can have even contradictory, so you might not have any solutions. Yeah. So for example, having the x and y actually is very strong. It's so strong, in fact, I think you can just solve this in one step. But yeah. Yeah, so basically, and so this is something that's definitely not going to be in the intermediate part, but you know, learning this is actually a good foundation for your algebra as well, right? Because solving equations and stuff, it's kind of a little bit different than usual, because usually you don't get control over the variables. Yeah, usually the variables in the equation are the things that you're trying to find, right? Here, so basically here you got to sub in x whatever you want, sub in y whatever you want, and just keep doing it until the condition appears friendly to you, or familiar. Okay, so that was like a 10-minute summary of functions and
you can have
functional
like
equations.
functions mapping functions to functions.
Yeah, so I would like to write a functional equation one day where it's like where the functions, it's a normal equation with functions. So you're not looking for the functions, you're still looking for the variables. Like I don't know, something like a variant.
But isn't that just a differential equation? Like the derivative is a function that maps functions to functions.
Yeah.
So you can consider dy dx a function.
Yeah, sure. Yeah, so I guess you can take like another step back and be like, oh, find the function and have x and y also be functions. Yeah. So that's another way of maybe doing a functional equation.
Right, because when you the y is presumably d of fx of the
Yeah.
equals p of x.
Yeah. But so at the very beginning of this, I think the best thing to do is not try to solve like in one go what the equation is. I think the best way to start is just sub in values until you understand something. Okay.
Until some kind of pattern emerges.
Yeah. So so let's do this problem in this.
Yeah. I remember the AMO for FEs are like pretty easy. What are you talking to?
Sisi,
Who's that?
the guy who was going to come here, but he's on the stream now.
Oh.
You don't come on Tuesdays, right?
No, because we have
You wouldn't know.
King's School is like sport. You have sport. You
On
have
Tuesdays.
You have sport.
Do you still play chess?
Yeah,
Kings?
chess on Friday. Yes,
You do? Are you intermediate?
I'm senior. I think.
Oh yeah, you're senior. Damn, now I can't beat you.
Wait, did you ever beat?
Yeah, I beat you in a competition in the one day.
Oh yeah, because that as of that counts.
It does. What's competition?
No, I mean like it's literally.
No, it was an hour. It was 40 minutes.
No, one day.
No, oh no, it was a 2 day.
Wait.
Yeah. It's like autumn 2 day 2018 or something. That's when Mr. Curry still was at James Jones.
Very exciting. Where's Mr. Cool?
Oh, you know Mr. Curry?
Yeah.
He left in year 7 when I was in year 7.
Oh,
Okay, so let's do this problem as like an introduction to functional equations. I mean, there's some things that will be really helpful no matter what the question is. Okay.
Well, you see that there's
So-
2 times on the right hand side.
Yeah. So for example, okay, so if all the things that are on the outside are f of something, right?
yeah.
If there's no x here, then constant solutions will work. Okay. Because if it's constant, you're just solving an equation basically with constant. You know what I mean?
Yeah, but
Like
now
x. x equals 2x plus 0 or something,
Yeah,
right?
but now
But with the x here, that doesn't necessarily work. But actually, this helps you a lot. This gives you control of everything. Basically, you can make x anything you want, right? So you can make this function output anything you want, basically. See, that's kind of crazy, right?
Can you not like factorize?
but like
it
how?
outside?
Like don't you have an y plus 1?
I know, but the y has nothing to do with the x, right?
Oh,
So whatever this is, you can just adjust it so that this outputs whatever you want. So another way of saying that, for example, is f is onto. So this is not. This is maybe more like me teaching functions than me solving this problem. But so usually f is onto. So this just means that
surjective.
yeah. So this means it outputs every real number. Okay. And that usually happens when there's like an x on the outside.
Oh,
yeah.
because you can put f of y plus 1 to anything,
Yeah.
just a random number, and add whatever to it.
Okay. Okay. 1 to 1. So what does f is 1 to 1 mean?
Means that you can't have f. That means f of a equals f of b means a equals b.
Yeah. So essentially, it means like every output is unique. Yeah. Like there's no repeated outputs.
The function is reversible.
It can be reversible if the domain is codomain is restricted to the range. Yeah, it will be reversible. Yeah. It has to be onto as well to be completely reversible as written. Yeah. Okay. So this is not necessarily like.
But with functions.
So I've not proved that it's 1 to 1. Yeah. But one intuition for seeing things that could be 1 to 1, right, is see what it means to be 1 to 1 is if two things go to the same thing, right?
It's not 1 to 1.
It's not 1 to 1, right? And the fundamental thing that's happening is you lose information about
Yeah.
Yeah.
For example, if I told you my number is 25 and I squared it, what's my number?
yeah,
Like you can't tell. Like
yeah. So when that happens, it's not 1 to 1, right? But if the x is back on the outside, yeah, it's like it's as if you recovered the information. See? Does that make sense? Something happened to x, right? But you still know what it is. You know?
Can you not do like 2 times x plus f of y plus 1? It seems like very similar to the left side.
oh, 'cause-
Yeah.
wait, just for convenience, can you sub the y out for something like
Yeah.
equals 0 just to make
Y equals 0.
clearer?
Yeah. Hold on one sec. Okay. So the stuff that you needed to output at convenient times, right?
Oh,
Okay. Okay, so those are sort of maybe second tier observations. The first tier observations are more like subbing in values of x, yeah? So you're basically your best friends are 0 and 1 and variants of those, and sometimes you don't have them. But here you have like, so what if you sub them both equal to 0, for example? So it's like the f of 0, f of
So you just get the f of 0 is equal to 2 times the f of 1.
2 times f of 1, yeah? Okay. And then, so maybe 1 is interesting. What if you sub in 1 for something?
Y equals 1.
Yeah.
yeah, y equals
It's actually kind of annoying. Why is it so annoying?
x equals 0, y equals 1.
X equals 0, y equals
F
1.
of
So
1.
f of 1. Well, it equals
2 f of 2.
2 f of 2. Okay, so actually this question is a little bit annoying because it doesn't help you much with this, yeah? But maybe when this doesn't help, sometimes, so this is subbing in values of x and y, yeah?
Yeah. Or you can just keep one variable and sub one.
So for example, 0 and 1, yeah? But you can also sub in values of f to check if something's a solution, right? Yeah. So one of the most common things to substitute for f are the sort of the common functions that you know, right? So for example, like if you have f of x equals x for all x, yeah? That's called the identity function. Yeah?
Or the do nothing function.
Yeah, so the do nothing function, it takes the input and it outputs it.
keeps the x.
So this is an example of what's called, I hate the word linear function because that's going to get confused with terminology in linear algebra, but it basically has the degree 1 polynomial functions, yeah? So it could also be like f of x equals ax plus b for all x. And then a, b constant, yeah? Okay? So if you try those things, you might get the solution, yeah? And sometimes you might get all the solutions without knowing it works. And knowing solutions guides you to how you prove it, yeah? Because you don't expect to prove something that's not true for the actual solutions, right? Which is crazy, because sometimes you prove, like, if a zero is a function, yeah? So if a zero function, right, does not work, yeah?
Because there's stuff outside.
Okay. But if the zero function worked, you couldn't prove it's 1-to-1, for example, right? Okay. So f of x equals ax plus b. Now let's try these things. Does the identity function work?
No, because it's onto.
What do you mean?
Oh yeah, sorry.
The identity function is also onto, yeah? So if you put the identity in, you get x plus y.
Oh, you said a constant. X plus y equals 2x plus 2y plus 2, which is like
2y plus 2, right? So that doesn't work, yeah? So the identity function doesn't work. Okay, what about linear functions? So not all linear functions work now, right? So there's some condition.
f of x equals x plus 1
F of x
equals x plus 1.
oh no, ax plus b. Oh, you want to do x plus 1 first? Yeah, sure.
Just do some easy ones first.
Yeah, so let's do easy ones first.
Whoa. Stretch this so much.
So try f of x equals x plus 1. Okay.
Very cool.
And and these are the nice examples. They don't actually have to be this nice. Yeah, they can fluctuate and stuff. This is like a nice. Not all functions have formulas, by the way. Yeah.
Are there? There's
Wait,
functions. Yeah, there's functions that need an infinite number of parts to do.
Are you thinking about like trig functions, right? Like they're the parts that make formulas work, right? So if you didn't have the trig function, or what's the formula for the trig function? It's the definition. It's its own notation, right?
Isn't it the Taylor series?
But then you have to sum up infinitely many terms.
Yeah, I know. That's an infinite function.
Yeah, so that function you have to be careful how to even define that. Okay, so f of x equals x plus 1. Let's try that. Okay, so you have x plus f of y plus 1 equals 2x plus 2y plus 2 plus 1. Yeah? And then this is y plus 1 again. So x plus y plus 2. So this doesn't work again.
Number 1.
Huh? So this will give you 0 equals x plus y plus 1, right?
Yeah.
But you need to be true for all x and y.
Yeah.
So that doesn't work, yeah? Is there a way to make the constants happen so that works? Yeah?
Yeah, there is.
Can your function be in relation to one of the numbers?
Which numbers?
So like, can your function be like, you have like 2x plus something, right?
Yeah.
Can your function be like inputted as like 2x something? Output as 2x?
Yeah, so like if a is 2 and b is 0.
No, like can your f of x, right, be like in relation to like another thing that you have?
F of x b. It shouldn't depend on some value that's not being defined.
Yeah. Can it be dependent on a value that's not defined?
Yeah, it can't. So function is like basically the thing which like is like the it's the mascot for determinism, okay? Like it's like a very cold logical thing. Like something exists and then the function is defined on that, you know? Okay, so f of x equals ax plus b. Try that, yeah? A x plus f of y plus b equals 2x plus 2ay plus 2a plus 2b. Okay, what happens here? Then it's ax plus a squared y plus ab plus b equals 2x plus 2ay plus 2a plus 2b. Yeah? You see that? This is work that you guys should be doing, actually. I've done this too many times, and it benefits me none. Okay? Subbing in stuff. If you make a mistake here, then you've lost all the solutions that you could have had. Okay?
Yeah, like here. X plus ay.
Okay, so for some reason the constant things are not cancelling.
What? It should be like that. It should be.
See, if you cancel some of the terms, right? So you get a minus 2x, yeah? Plus a squared minus 2ay.
Plus ab minus.
Yeah, or you can put it the other side. Equals b minus, oh yeah. B minus ab plus 2a.
2a, yeah.
Yeah? Yeah. So basically you need this to be 0, yeah? See that? Because if it wasn't 0, the x would go out of control, yeah?
Wasn't a? You mean a minus 2 equals 0?
Yeah.
Yeah.
Right? So if a equals 2, then that makes that 0. That's 0 as well, right?
Yeah.
And then you get 0 equals
b
b
minus 2b plus 4,
plus 4, yeah? Which forces b to be 4. Does that make sense?
so f of x equals to 2x plus 4.
Oh, so this is great, right? This is actually the first sign of progress. So you actually have that f of x. So this function, okay, if a is equal to 2, and b is equal to 4, yeah? Then you get f of x equals 2x plus 4, yeah? Works, okay?
And that's the only linear function that works.
Yeah, not only is it works, it's the only function of this form that works, okay? So there's lots of things that could happen from here. Unfortunately, it's too common that this is usually the only function that works. So it kind of leads to some logical fallacies saying that if you find one, then you're done,
Yes.
okay? And you'd be right, and that's the problem, right?
In general.
Okay? But
Because like
in
normally-
principle, yeah, so the main thing that beginners need to be aware of here is they have to actually show that no other functions work. Yeah? Okay. And this guides you to showing that. For example, if you wanted to show that no other functions work, then look, your function is onto, yeah? Your function is 1 to 1. So these are all nice things you could prove, okay? Your function has all these properties. Okay.
I mean,
I think unfortunately this question,
with Michael,
yeah.
could you not see that it's like something to do with 2x plus 4? Because like,
Yeah, I think you see it, yeah.
because if you like factorize the right hand side,
hmm
it's 2 times x plus f of y plus 1, right?
Yeah,
And the other side is f times x plus f of y.
yeah,
It looks very similar.
yeah.
It's like double almost.
Yeah, so you're doubling it, right?
Yeah.
So you're kind of saying like you're saying like this is exactly the sort of thing that will satisfy, yeah. So now you just got to prove it, yeah. So I guess I'm not gonna go around about the bush if this is the way I saw it. I'm just gonna show you the way I saw it, okay?
So yeah, this is actually pretty tricky functional equation.
Yeah, but so there's one key thing you can do, yeah. Set y equals 0.
Because y, I feel like y needs to be like constant because
Yeah, set
x
y
isn't
equals 0.
anything.
Okay, look what happens once you set y equals 0, okay?
If f of x plus f of 0 equals to 2x plus
Yeah.
wait,
Sense? So that's the answer right here, see? Because look at what is it saying? This is a constant, right?
f of x plus a constant.
F of x plus a constant. Well, the point is x plus a constant
Oh,
represents any number at all, right? So x
equals
plus a
to-
constant is basically just x, yeah? So f of x is equal to 2x plus 2 times a constant, yeah?
which restricts it to only linear functions.
Yeah,
And then we already proved that the only linear function that works is 2x plus 4.
yeah. So for example, so now you have to do, this is a kind of funny operation. So you gotta, this is kind of a funny operation because you forget about what x actually is. So I can take x and replace it by x
X
minus
minus f of 0.
Okay. But in reality, what I can do is I can like because the point is for every z, there exists an x for which x plus f of 0 is equal to z. You know what I mean?
Oh yeah, because f of 0 is a constant.
Because this expression is onto, if that makes sense. This expression covers all the real numbers.
Regardless of what
Yeah.
f of 0 is.
So
So basically, it might be
yeah.
less confusing if you said x equals to a minus f of 0.
Yeah, I can do this, okay? So I can do let z be any real number, yeah?
Yeah.
Arbitrary, that's what arbitrary means. Okay?
Oh, so z.
Yeah. So if I let z be arbitrary, then I can set x equals to z minus f of 0, right? Because an arbitrary number minus f of 0 is still a number, and like x can be anything, right? Then I have f of z minus f of 0 plus f of 0, right?
Equals to 2 z minus
2z minus 2f of 0
plus 2 f of 1.
2f of 1, right?
So then you just get f of z equals to
So then you get f of z equals to 2z
minus
plus 2
f
f
of
of
1
1
minus
minus,
f of 2.
yeah?
Yeah.
That's just the constant, yeah?
And
So this shows it's a linear function because this was arbitrary, so this is for all z, yeah? So it's actually a dummy variable, yeah? So this corresponds to the move x goes to x minus f of 0, and that gives you f of x equals the same thing, right? 2x plus 2 f of 1 minus f of 0, yeah? So the overall effect is the same as this, except you're using the letter x instead of z, okay? But the point is that the letters are dummy variables, yeah? Because they've been quantified, yeah? They're meant to represent all the values.
I mean, if you don't use that, you're
So basically, functions describe expressions. They're not.
So basically,
Not an equation. They're not equations. They're
a function.
expressions.
So in school, a function is like a formula, okay? And usually they're continuous because formulas are continuous, yeah? But in general, a function is just basically like a whole lot of pairs of values,
But they're also just expressions because you're not having actual like numbers in it. You're just like,
Well, I mean, here you're actually lucky that you can express it so nicely, yeah? Sometimes the function is not so nice. For example, the function could take an input, right?
Yeah.
And the output will be 1 if it's a rational number and -1 if it's an irrational number. That's a function, right?
Yeah. You can't.
And so that expression, that's almost an anti-expression, right?
oh,
This function is basically like a machine. Like that's kind of the description that you got.
Yeah. Okay, does that make sense?
You got descriptions function as a machine.
So this proves that the function has to be
Yeah.
this proves that the function has to be linear, right?
Linears.
And we said that all the linear functions had to be that. And we should actually, and this process also checks that this works. Yeah, we should also check that the function works directly. So if you're writing a proof of this, right, you wouldn't need to do all of that stuff. Well, actually, you would need to do that stuff. You wouldn't need to do the x part. You wouldn't need to do the x-1 part. Remember?
Yeah, because subbing in value.
You wouldn't need to do the 0, 0. Yeah, you just need the parts that contribute to the solution. Yeah.
It's like, but the thing is, you don't know what contributes to the solution. So when you're working it out, it's good to try the first few cases and see that they don't work.
Yeah.
See something.
And if you left it like that, I mean, you might get full marks still. It's just sometimes when you focus on the solution again, the people can give you marks more efficiently, and you get to sort of check your answer at the same time.
Yeah.
So, but imagine if you're doing it for the first time, you just write it out. It's right, but it's not necessarily direct, but it's still going to get you the mark.
If you, the more indirect, empirically, the more indirect your solution is, the more likely is it to be wrong.
Well, I mean, people do make mistakes abstractly.
Very good.
When I say empirically.
Okay, does this make sense? Any questions?
It's fine.
Yeah, see, the fact that you had the 2 variables actually really helped you a lot. It didn't harm you at all.
No.
Oh, Orlando says he thinks he gets it. That's really cool.
Getting it is like the first step of doing it.
Yeah. No, you guys are really smart because I don't even get what I'm saying. Like, you do. That's cool.
What? How do you not get what you're saying yourself?
Because I don't have to listen to it and understand it. I just have to generate it.
Oh.
You know what I'm saying?
True.
Yeah, you can. It's surprisingly easy to just say a bunch of like crap and.
Yeah. Because I get to say the stuff after the choice has been made, if there were any choices made. You have to understand it before the choice has been made.
Wait, really?
Because part of the understanding is to understand the choice, right? Not necessarily just the fact. So I guess that's the difference in understanding the solution as correct or as something that you can come up with, right? It's whether to deal with the logical consequences or to deal with the choices. So the higher level, I think now I can express it in words, is to deal with the choices. Once you eliminate the choices, it's determined, yeah? Yeah. Actually, the choices, it comes up in maths quite a lot. There's even an axiom of choice.
Is that related to making choices?
It's related to functions, okay? So the axiom of choice is related to defining an inverse function on something that's one-to-one, that's not one-to-one, but onto.
Oh, okay. So the axiom of choice, which domain you take.
Which one to choose, right? Like plus or minus, you know?
Do plus or minus square root.
So the fact that if there exists, obviously there doesn't exist an inverse function, right? Yeah, but there could exist like a partial inverse. So like it could go back and it cancels one way, not the other way, right?
Oh, yeah. So
and the existence of the partial inverse, okay, is basically the axiom of choice. So what it's saying is you can choose infinitely many plus or minus signs at the same time, like if it was a square root, right?
Yeah.
Does that make sense?
Oh, because you can define, it's like the f of x squared is one thing.
Yeah, so you can define a function backwards, but that squares, so that the square cancels, right? But like if you squared it first, then define it backwards, it wouldn't necessarily cancel that. Yeah.
So yeah, it's like
No, it certainly doesn't cancel that. Yeah.
we've done in school that like restricting domains. What is the largest domain that this is an inverse?
Yeah, those questions don't make sense, right?
They don't.
Because there's infinitely many domains for which it could have an inverse, right?
Oh yeah, but yeah, because like some of them might not have. How do you define biggest? Like
Yeah, so there must be continuous, right?
Yeah.
So like if you're defining the domains on which something had an inverse, yeah, like for example, yeah, in school it's like this, right?
Yeah.
And you say like, what's the biggest domain it has an inverse, right?
Oh, that's
So
that.
you're like, it could be that, yeah, or it could be that, right? Yeah, or it could be like an alternating, you know.
Yeah, for every like whatever rational numbers this side for
Yeah.
rational numbers.
Yeah,
So like I guess
and you can actually talk about size because you can talk about the measure of it. But if it's too disconnected, it could just have measure 0. Then it would be the smaller. That would be small.
yeah. So like I guess that's what I mean by like large domain. Like
But you can certainly do it like this, right? Let's kind of be more cheaty and just you can get this whole interval here, right?
Yeah.
And then you go the other way. So now there's no question of length because you can add the length now, right?
yeah. Now the length is equal
Yeah,
to
yeah. So actually, it's crazy when you go back and read these things. None of them make
they
sense at
don't
all.
make sense. They're not rigorous. So how am I saying? Yeah, that's for why I can't get like good marks on school exams. Because
Yes, only
every
that.
time I look at a question,
Only that.
I go like, wow, that's not rigorous. But if I try to make it rigorous, make any attempt to try and make it rigorous, then like,
How would you make school maths question rigorous?
because like I'm scared.
They're not meant to be rigorous. They're meant to be basic stuff.
Because they keep scaring you that like if you don't show full working, you might get like you might not get all the marks. But in their case, full working basically means you bullcrapped a lot of stuff.
Hmm.
You just wrote a lot of stuff.
You just wrote up what you do to get the answer. How working is you're not proving that the
No.
answer and everything else works.
It's not true.
Or unless it's quadratic or something where you have to actually prove that it works, which is really dumb because I got lost like 4 marks of it. Because I just like did it because it was like a sum or something. Like
Is
plus
this
minus
pen
thing.
dark enough?
It was like a plus or minus thing, so I did it.
So is this like a Venn diagram of the similarities and differences?
An Venn diagram. See, this Venn guy got such a huge
Yeah,
attachment to this trivial result.
It's like a metal. It's just
it's so trivial. It's like
It's almost like the smarter people didn't need the diagram. I'm being a dick. Sorry.
you're being more
what's a word man? It's saying true. This.
than that's just some really crappy result.
Oh, that's dark. Okay, so I thought of doing this before and I kind of forgotten it a little bit. But let's have a look. So let's see if I can try to remember what I was trying to say. Okay, so this is the senior contest intro. And maybe as part of this, for the interest of the AIMO people, sort of contrast between AIMO, because that'll be interesting for some people anyway, yeah? So I guess there's an exam structure. Topics. And then there's like prep materials, I guess.
Wait, is it open book? No, it's not.
And then I'll have like problem solving techniques. Actually, I've run out of space here. Problem solving techniques.
Wait, so what's the senior contest more of, like geometry and stuff, or like?
Yeah, these questions are about to be answered right now.
Yeah, like would asking the obvious.
Okay, for prep materials. So I guess the exam structure, first of all, it's similar. You know, the AIMO is 4 hours. Yeah, this is also 4 hours. Okay, but there it's like 8 plus 2 proofs. Yeah, and these have explanations. Whereas for the senior contest, these are like, this is a proof contest. Okay, so 5 questions, 7 marks each. Yeah? Proof contest. Okay, so basically the difference is here, like the proofs get you back the marks. Yeah, like if your answer's wrong, that's when you start looking at the proofs. Otherwise, you already get full marks. So the explanations give you marks. Yeah. Whereas here, I would say that it's the lack of explanations that reduce your marks. Okay, so here, not having the complete answer will cost you. And I think for a lot of people doing it for the first time, that's a big hurdle. So you could solve like 3 questions in principle and have only 2 questions worth of marks. Yeah, and so that will degrade you possibly from a silver to a bronze.
Wait, there's medals in this one?
Yeah, you have bronze, you have perfect scores, silver, gold, and bronze. An honorable mention, which usually is like a perfect score on 1 question. Usually,
Oh, so like,
that's the culture. I don't know what it is with this, but
oh, you can get like, you can actually get nothing on this.
you can get 0 on this. Yeah.
No, I mean like, isn't the A, for example, the AMO, they have everyone either honorable mention.
Oh no, you don't have to get an honorable mention.
Oh, you don't have.
No, you could have just unmentioned.
Oh.
Unmentioned. Yeah, but it's funny because you wouldn't say they're unmentioned because that would defeat the purpose of not mentioning them, right? You just
Like,
and
this
it's-
statement is false.
yeah, it's almost more dishonorable than just having it unmentioned.
Yeah.
It's like there was nothing special about his involvement. You know, like yeah. So you don't want to be singled out for not being mentioned. That's just cruel. Okay.
Don't talk about it. He just landed the test. True.
Okay. And then the thing is like this is like worth 5 marks each, yeah. And then the rest of these are worth like 35 marks, but it could be like 2, 3, or 4 marks, yeah.
Yeah, I'm pretty sure like I did the AMO, it didn't actually give us the mark breakdowns.
Yeah.
I don't know why is it in the context they don't actually give you the solutions back.
Your teachers know your score actually, the question breakdown even.
What really?
Yeah, because when I did it
They
for
didn't
your
tell
school, I got that,
me. They didn't.
and I sent it to the students directly. But I don't know if everything I did was just unpopular there.
Wait, what?
I'll explain this later. This is too much history right now. This is okay. Okay, so 4 hours, 5 questions, 7 marks each, and it's a proof contest, yeah. So this is the key one. So remember, I sent you this Udemy thing, which has some notes on how to write your answers, yeah. Yeah. So if you don't know that, it's on the link for yesterday's class. There's a Udemy course that has all the things I'm about to mention. Okay. All right. So the topics are interesting. Okay. So I guess the new topics. The topics that are most interesting, we just kind of mentioned, yeah? Functions makes an appearance, okay? And it seems to make an appearance as a topic, but usually even in the form of functional equation, okay? Yeah? So I might make functional equation a problem-solving technique because it's like having experience doing this type of problem seems to be very effective at solving kind of questions that come up with functions. Okay, and and also sequences, polynomials, all this good stuff in algebra. Okay, and I've found that in the exam papers, so the prep materials we have are all the papers from 2014 to 2019. Okay. You can find that in that Udemy course I sent you. Okay. Yeah. It has all the papers. Okay. So that's there's 6 papers here, right?
So yeah, that's not actually a lot.
Oh, I mean, there's only 3 weeks to the exam.
Yeah, because like and like you said that. Well, you said that we might run out of papers if we do them too much.
Oh yeah, but I don't think you have enough time to do them
Yeah,
too
because
much.
remember Kings.
I don't forget this thing.
Wait, what?
No, I haven't forgotten.
Oh,
Yes.
We have been reminded too much, true.
Okay, so 2014, 2019 has 6 papers, right? And actually, I think in like 3 of them, 3 or 4 of them, yeah, there was a functional equation as question 4 or 5.
Mm.
Okay, so like 3 or 4 functional equations appeared. So this is going to be a definite, and I think one of the reasons for that is because functions is a new topic, so the extra like sort of shock value already makes it more difficult just by existing.
oh.
So it's not likely going to be like question 1, you know, because then the people who don't think they know functions, they're just going to give up on question 1 when you kind of want everyone to have a go at question 1.
Mm.
So that's why it probably happens at question 4, question 5. Okay. So I think last year was a question 5. The year before that, it was like a question 4, 5. And the year before that was like a question 4. Yeah. So knowing functions, you have like a 50-50 chance that it's going to be a functional equation towards the end question,
Yeah.
like, sort of at this kind of level of an asks. And then it's geometry. So this is kind of nice. It's almost like the first time geometry. So you actually learn a lot more geometry in the AI mode than you can actually use in the exam. You know what I mean?
Mm.
And I feel like this is the time where it actually comes out. You can use it. Okay. But it's not really complicated geometry. It's circle geometry. Okay.
Oh yeah, so chapter 2 of the Jira book.
Yeah. So, and from what I see, it's kind of like 1 or 2 circles. It's not like 100 circles. Yeah. So like circles, maybe a couple of circles. Yeah.
Probably like the one I solved like in the BMO.
Yeah. Okay. So there's obviously in circles. So in circles, circumcircles, all the stuff we learned for the AI mode that didn't necessarily come up. So in circles, X circles,
Circumcircle.
circumcircles,
X circles sounds.
triangle centers, and all that stuff, right?
Or,
And then we're approaching the radical axis, but you see the radical axis has 3 circles, so we don't really have
wait,
necessarily-
really? Radical axis. There's 2
or the radical axis theorem or whatever.
Oh yeah.
The radical center. Yeah. So radical axis, yeah, there's 2 circles, so that could still help. Okay.
Circle inversions.
Yeah, so the thing about geometry, a lot of the stuff helps even if you don't need to know it, right? And so sort of the starting point might be sort of the tangent theorems, you know, like the alternate segment
Oh
theorem.
yeah. That one came up in the BMO law. Very useful.
Tangent.
I mean like the tangent of the
But this is going to be a good time. So I've noticed, I didn't really notice this too much before, but like coordinate geometry really helps solve, so for example, a lot of these simpler geometry problems, right?
yeah, because you can code dash.
Because they're simple enough that you can bash them, right? So coordinate geometry.
But like more complex it's
And especially for the more advanced seniors, this might be a good time to learn another bashing technique, yeah? So if you're already good at coordinate geometry, I think you might just have enough time before the test to try to learn one of these other ones. So this is complex numbers, yeah? And barycentric coordinates.
Barry Dash, which I didn't have time to watch because like
Yeah, I might send the videos through about these things.
I
But I'm actually hoping Sean will help me organize our information on complex numbers.
yeah, I think like
Because
all
I'm
your
starting to know more than.
complex
I
numbers.
think all your like emails got put to my junk folder for some reason.
Yeah, that happens with everyone. So the first time I meet anyone, it's like this.
Wait, why?
Wait, why?
Why does that happen?
I think there's something wrong with Outlook.
It's
I don't know.
Outlook, yeah, it's Outlook. Google and Outlook are enemies.
Yeah.
It's just junk.
Just junk. If you get an email from Google, it just goes to junk.
Yeah.
You get an email from Outlook, it also
Elitist.
deletes.
Yeetus deletus.
Elite.
What are you trying to get?
Oh, okay, so it's chess.
Yeah, so
Like,
so
always
the
learn
reasoning
chess.
behind I think why bashing seems to be very effective is because the simplicity of the kind of questions, yeah. So it's kind of like Tournament Towns where the questions are not too complicated but they're tricky. So like bashing it gets around the trickiness, you know what I mean?
It just makes it more.
Yeah, it could be psychologically tricky because you approach it a certain way. But obviously I would love to see. Okay, so and geometry, the problem in geometry always like happens at question 4 or 5. Okay, so we have like a question 4 or 5. These are like question 4 or 5s, yeah. Okay, so in one of the years, out of all these years, there was like combi question or number theory question at the end, right? All the other years, it was 4 and 5 was geometry and functions. Okay, and it kind of makes sense, right? Like if you want the test to be decided on
1, 2,
something,
3. Algebra.
1, 2, 3 is just random. Like sometimes the one on polynomials is question 1.
Polynomials, algebra.
But the point is, it doesn't matter what the topic is. It should be easy for question 1 as long as you know the basics. So they shouldn't make it too scary
So
for question 1.
basically, it's not that hard to get honorable mention.
Not that hard, but if you expected it, you might not get it. See,
Oh,
because you didn't try, like you didn't find your mistakes.
Oh, I get it.
Yeah.
Like if you
Like if
You
you just
always
did
get
one question
less
and
than-
banking on the honorable mention.
like if you
Wait, so
you
just
always
accept
get
it.
lower than you expect. That's like an idiom.
Idiom.
Yeah, you
That's
always
just the fact of life.
I guess.
Yeah.
Well, it depends on your
That's fine.
personality, though.
you always get less than you expect.
I mean, no, you could be a pessimist and like.
Or you could have a
like,
higher
really bad.
standard of rigor than you could possibly even write down.
What?
Like you could have a higher standard of rigor and you just think you didn't prove it, but the person marking it
Oh,
thought you did.
what do you mean standard of rigor? Is that even a subjective thing?
Or they could be like,
little
they
bit,
could just
I
like
mean-
not understand what you wrote,
Yeah.
so they give you full marks. True. Like you got your answer correct, so they give you full marks.
Well, usually they understand something about what you write to give you full marks, but they don't understand the difficulties. That's the problem, yeah. Okay, so question 4 and 5 seem to be very circle geometry and functional equation heavy. Okay. And I don't really know too much about L. So in terms of our preparation, okay, we have basically in these years, 2014 question 2, 15 question, was it 3 or 2? 3, 16, and everything else, they're all question 4s, yeah? That we haven't actually done in the form of a video, I guess. But all the other ones are actually part of the Udemy course that has all the videos to the solutions, yeah? So if we're going to present questions separately, then these are the ones that are going to be highlighted first. And maybe this is question 3 as well. And also any geometry question, I would love to see the different various solutions, yeah? Yeah? So in terms of bounties, there's like a bounty on all the geometry questions and the question 4s in all these papers. And obviously the 2019 paper was just last year and we hadn't actually gone through it. Okay. And then the question 2 and 3 and 14 and 15. Okay. Actually, I have a list of this.
I feel like the intermediate AMC papers get harder like the early Evo.
I
What?
think so. Well, yeah.
What do you mean?
All right, let's
Some
stay on
recent
topic.
papers
Stay on
aren't that
topic.
hard compared to like previous year papers.
Okay.
Wait, what?
Yeah. So, and also basically, so when you practice, right? Okay. So the people who are doing it for the first time, I expect you to start practicing basically this week. Yeah. So, obviously my expectation is not a forceful one. Yeah. You can do whatever you want, but like the point is, try a paper under time conditions. Yeah. And you can even try to get me to mark it, but I would also like you to just watch the videos for the ones that have already been done and get me to mark the ones that haven't been done. Yeah.
Oh, there's a big bounty on their heads. Like,
Yeah. So-
score.
If we do break up some of the papers and show the questions, you could also reorder the questions and make them a paper into it. Yeah. But the important thing when you do that is if you mix and match questions, you have to get like a question 5, for example, and a
Oh,
question
you have
4.
to
You have to have the harder questions, okay? And the harder questions have to be in different topics, okay, for it to be realistic. Okay, it can't be 2 geometries and you're like good at geometry or terrible at geometry. Or maybe if you're terrible at geometry, it's actually better. Okay.
Basically, you're trying to make it as hard on yourself as you can.
No, yeah, well, it depends. The first time you just want to have an idea what it's
I'm just
like,
terrible at
right?
geometry, right?
Okay. But once you've run out of senior contest papers, so the NZMO1 has some interesting questions. Actually, the BMO1 probably more similar to the
What's
actual
the
test.
difficulty difference between AMO and senior contest?
So I think question 5 in the senior contest is probably like a question 4 or 8 in the AMO. Maybe a question 4, or a little bit easier. And 1 to 3, well, we'll see. Okay, we'll have to figure this out as well. Yeah. Okay. And then if you kind of progress beyond this, and then there's the Canadian Maths Open Challenge, which the exam format is quite different, but the difficulty is quite similar. And then, of course, if you want to go beyond this and you've run out of this, there's always the National Olympiad stage. So NZMO2, BMO2,
And AMO?
of course, AMO, but then we need to practice AMO later anyway.
Oh yeah, because
And then there's the Canadian Maths, and then there was like the Indian Maths Olympiad. There was some questions that haven't been done. So here it's question 5. It's question 5 and later. Yeah.
Me and CJ were doing Indian TSC. They were pretty interesting. Some geometry ones were just super big.
Yeah.
how do you define
Um,
geometry from being
have I forgotten anything? Yeah. So basically, try a paper a week. Yeah. And we want to basically have different solutions for the geometry questions. And I guess I also kind of want to go through the Australian scene stuff just to sort of get you an idea of what answers have been accepted, you know, because it's one thing to say you like accept these theorems as reasons, and another thing to have actually someone have accepted those exact theorems as reasons. Okay.
Oh, it's basically like the school standard.
Yeah.
Like
Okay. So topics, new geometry, circles.
When you forget the formulas.
I mean, yeah, and then there's all this other sort of combi like recurrences, sequences, number theory. I guess I would like to talk about Chinese remainder theorem because that's something we never covered before. But I guess Chinese remainder theorem could actually come under AIMO or even ANC. But it turns out a lot of the times that we did some problem where the prime kept on, like it was like mod of prime and the number kept going +1, +2. It actually turned out to basically be Chinese remainder theorem without us knowing it.
alright, have we done Chinese remainder?
Maybe we can do it today a little bit.
We want to focus on like probably geo.
Okay, we can do a geo too. Okay, so are there any questions? Oh, so this should be 25 marks, not 35.
Oh, 35 marks is the entire
Yeah,
exam.
this is 10 marks here. So here's 35 marks.
Again, you have to like get at least go bronze in AMOC to get an AMO this year.
Yeah, so I guess another thing you might want to know is the senior contest affects. It's like the AIMO for seniors, basically. Yeah. Okay. That's all I wrote. I don't want to emphasize anything else about that. And then the other topics, I mean, combi and number theory.
Combi we just did in school. I don't know.
You did combi in school?
Yeah.
How did you do combi in school?
No, I mean like actually.
Yeah, so the combi is starting to be more in school, yeah, because you learn like N choose R in school and
Yeah.
stuff, and that does come up.
Binomial theorem.
So that does come up as a kind of question. And the number theory, I guess it gets a little bit more advanced, yeah. So I don't know exactly how to explain these topics, but I don't think we quite get up to quadratic reciprocity though. So primes maybe. So this is so we're well over fundamental theorem basically. and then primes
What are you doing?
and mods. Okay, but the focus I want to have is on the algebra and the geometry because that's the new stuff from before, and functions is kind of new. I think I'll talk a bit about combi tomorrow. Okay, so here there's also CMO, Canadian Maths Olympiad,
Chinese.
India. No, we didn't have Chinese Maths Olympiad here. That's too hot. Not for this. Not for this. Okay, so yeah, so
To be honest, the Chinese probably do Math Olympiad questions at school.
not necessarily. There's a lot of people. You don't know how the IQ spreads. It could be really thin at some places. Okay. Anyway, so any questions about this? So basically, I want to experience sort of like the difficulty level of the senior contest, and then people need to experience it under timed conditions, and then there's all these resources. So basically, in that Udemy course is all these papers, yeah, and it also has a list of the questions that haven't been done, yeah. And I think I'll send you some of these problem-solving techniques. So we already covered Barry Bash and stuff. I might send you that video series or whatever. But yeah. So I would like to see people be able to solve functional equations, and I would like to see people have many different solutions for the geometry problems.
Yeah, because like
Okay.
there's always many different solutions for geo.
Yeah, especially if there's not many circles and stuff.
Then there's always a code bash solution.
All right. Any questions? Everyone following?
Yeah. Yes, sir.
Mm-hmm. All right, so I might break up some of the 2014 stuff.
So I guess I'll just have to make do with the time given. I think, we're even given a study day to do our trials.
Mm-hmm.
Yeah, the study day, like, because we're doing the HSC trials.
Tomorrow,
I mean, like, I think
this
next
is
week.
so much better for my feet.
We're doing the year 12 HSC for advanced next week.
Oh, next week.
Yeah,
Trials.
And then and we get a study day before. The teacher said you have to study maths, but he didn't specify that you have to study for that.
Oh. Do you have any close competitors at your school?
What?
Anyone
Is everyone
close
else good at
competitor?
maths?
Oh no, they're just really good at school math. There's like 10 people ahead of me in school math because they can do stuff faster.
Oh.
No, but for Olympiad math, there's only Kevin.
Okay. Huh. The time limits are really short, huh?
Huh?
Time limit's really short.
Yeah, for school exam. And yeah, you either make a bunch of silly mistakes or you don't finish.
Okay, so I want to present. So let's do a little bit of geometry. So this is a question. Once I put this up here, I want to see more than one solution, right? I'll sketch sort of a solution, but maybe only a part of it.
I mean, but there's always one code bash solution. So I guess by definition there has to be more than one solution.
All right. So which question is this? So I want to do. It's like a circle. Okay. I didn't really know how to label this points, but so this is circle 1. This is circle 2. Okay. Oh crap.
Why do they use that symbol for circle?
I think I just made that up.
What letter even is that?
It's a gamma, capital gamma.
Oh, really?
It looks like a graph.
Oh, the symbol for a graph. Yeah.
Oh, yeah, so there's what's the question though? Are any of those circle centers, is that the diameter?
Okay, so the question asks, basically, okay, yeah. So basically the question asks, so let me tell you what year this is from, just so you don't, so you're organized with your list of years. So this is 2018 question 4. Okay. See, it's an example where geometry came up as question 4. In that same year, question 5 was a functional equation. Okay. So basically the question says this angle here, yeah,
Why?
the red angle, yeah. Red angle, yeah, is 90 degrees if and only if
The red triangle, it lies on the black line is the diameter.
if the center of gamma 2 lies on gamma 1. Okay. And I want to focus on, like, let's show one direction, yeah. Show. Oh, you can show either direction actually, but I'm gonna show you 90 degrees implies. I'm gonna do a sketch of why 90 degrees implies center condition. Yeah. Does that make sense?
Yeah, because it's even only.
Yeah. I'm only gonna do one direction. Yeah, so you can already see the logic has already implicitly assumed that you know what if and only if means in this exam, right? Which I don't know if that was a feature of AIMO.
Really, proof contest. The AIMO proofs are much more intuitive, I think.
I should label some of these points. So this is P, Q. This is A. This is B. This is C. Actually, yeah, this point is D. Does that make sense? You have two circles that intersect, yeah? And the tangents intersect at P from the point of intersection. And one of the tangents continues to C, and the other tangent continues to D, right? And then the A and C have external point at Q.
Yeah.
No, sorry, I don't want to show 9 degrees. I want to show center condition, yeah? Show center condition.
Implies 90 degrees.
Implies 9 degrees. Maybe other people from the chat can tell me how independently, perhaps. I want independent proofs.
Oh, because you don't want it to be a trivial like reversal.
Yeah.
Trivial converse. A lot of times in geometry, this is just a trivial converse.
Yeah, so in this case, I would also like to know. So this is, I guess, a kind of a geometry problem you have to overcome to break the
Silver barrier.
yeah, silver gold fish. Because
Well, P is the center. That's also immediately a lot of things.
P is not the center. The center is like here.
Oh, okay.
Center condition.
The center condition means the center of gamma 2 lies on gamma 1.
Well, it lies in
Like on.
on.
Directly on.
Yeah, so like it lies like here.
And 80 is diameter, right?
Well, no.
No.
Oh, just a random. Oh, it's a tangent to that one. Never
It's a
mind.
tangent, yeah.
Wait, can you not do this with like the coordinate geometry gradient stuff?
So I'll sketch a coordinate geometry proof. I won't actually go through the proof. I'll just do like a 5-minute sketch.
Yeah, because like it's just chord.
Yeah, but it doesn't have to be that's not the end of it, yeah? That's the nice thing. Like I can kind of ruin the solution to this question and still have the question be open, yeah?
Yeah, like because of chord dash, like you can spoil the
Yeah.
solution without actually spoiling the essence of the problem.
Yeah. Kavan always chord bashes everything. That's what Sidra says.
Yeah,
Yeah.
plus he.
Of course, wait, is AD the diameter or something?
No, we've been through
Tell
this.
him it works.
Huh?
Say it works.
Okay, maybe I want to get rid of the chord bash. How about this? Okay.
Yeah, sure.
Okay. Okay, so I want to sketch a solution. So this is actually one me and Orlando came up with, the chord bash, yeah? So it makes it easier if you realize, okay, so first of all, I want to make it very clear, okay? So there's the other condition is still open. When I'm doing the chord bash solution, the question still needs to be done somehow by a synthetic, right? Just geometry. It needs to be done by complex bashing. It needs to be done by Barry bashing. I don't know how Barry bashing can come into this very easily, but maybe complex bashing is something, and synthetic solution is also desired, okay? And then also I want to see kind of possibly independent proofs of the converse and possibly dependent proofs of the converse, or proof of this based on the converse, yeah? That makes sense? So independent proofs with and without converse, proofs with converse assumed, and synthetic complex numbers in coordinate geometry. Okay? So here, I think one observation you can make, if you assume the center lies on that circle, yeah? So if you assume center condition, yeah? It obviously helps to draw a big diagram, yeah?
Yeah.
If you assume the center condition, it's kind of like this. The center is like here, right?
They say the chances of you solving the problem is directly proportional to the size of the diagram.
No.
Size isn't everything. Okay.
I have such a direct, tiny ass diagram. I
But
should
sometimes-
not be able to
sometimes,
solve
like-
problems.
So
It should be
I've actually
tiny.
seen other people think the same thought as me on this. You can actually have a ton of really small diagrams and it helps. So that's because I can't draw very good diagrams. Sometimes I draw a ton of small ones, it actually helps.
I just draw small, so it should be mathematically impossible for me to solve geometry problems.
Well, assume the center is the center condition, then you will know like
Yeah. So assume the center is here, right?
then you
On the
know
circle.
that it's equidistant to A and B.
Yeah. So the first observation that helps you here, can you see that because the center is here, right? The radius is perpendicular to the tangent, right? So that means this is 9 degrees. Yeah? That makes sense?
It's also 9 degrees to the other one.
Yeah, so that means this is the diameter, right? So it actually means the red line here is a diameter. Yeah? So the red line here is a diameter. And
PQ.
the PQ part, so that's like this part, right? Yeah? Just like that, yeah? Okay. So you want to show us 9 degrees, yeah?
Yeah.
And I want to show it with chord bashing. So basically, like if you chord bashing and it's not like really straightforward, it means that probably you could be better at geometry with synthetic methods. Because like it might not be the best way to see it. It's just that you happen to be better at that, so you sort of doing it that way, yeah? Okay, so one of the things I want to emphasize is somehow avoiding using the equation of the circle is really important in chord bashing, okay? And trying to like minimize computation is pretty important.
Or minimize curved things.
Yeah, so here, for example, I could let the x-axis, I could let gamma 1 be the unit circle, where this is the x-axis, yeah? Gamma 1 unit circle. Yeah? And then I could let this line here where they intersect, the radical axis, be at x equals a. Yeah?
Isn't that why don't you set that as the origin?
Here's the origin.
Oh yeah.
Actually, I don't know. I actually never actually thought about where to put the origin except for on this line. I just kind of put it there, yeah? But it kind of worked out, so maybe that was lucky. So if you put the x-axis here, right? Then can you see that? So the coordinates of like the center of the circle, the coordinates of P, and the points of contact are kind of really obvious, yeah? So all the points that are in the question have obvious coordinates, maybe except for C and Q, yeah? Does that make sense in terms of A? Is that obvious?
Yeah, it's like they're all just perpendicular or something.
Yeah. And actually what Q has to be is actually obvious as well, right? Because it has to be perpendicular in the end, yeah? So you don't actually have to find Q and then test the perpendicular. You can just take the perpendicular. So Q has to lie on this line and we have the same X value as P, right? That makes sense?
I'm assuming circle condition and proving it's perpendicular.
Yeah, I know, but you just have to check that that's the right point, yeah? Because there's only one point that's perpendicular and on this line, right?
Yeah.
Okay. So, so you basically know the coordinates of Q, right? So then the only thing you need to find is essentially the coordinates of C and the equations of these tangents, right? That makes sense? Okay. So the only part of this chord bash that is not already basically known is the coordinates of C and the equations of the tangents, yeah? But the equations of the tangents are actually obvious, yeah? Because you know the slopes.
Huh?
You know the slopes of the tangents because it has to be perpendicular to the radius, right? So since you know these points, you know the slopes, so you know the equations of the tangents, yeah? So the only thing that's not obvious in the chord bash is the coordinates of C, right? Even though you have the equation of this line and the equation of this circle, yeah? So at worst, you'd be solving that equation, yeah? But actually, you can find C without doing the circle because C has the property that AC is perpendicular to the center of the circle to Q, right?
Oh yeah.
Yeah? So then you just need to find the straight line now to find C. So now C is the intersection of A, the line going through A that's perpendicular to QO, right?
So the thing with chord bash, you just try to avoid circles in general.
Yeah. So what I'm saying is I'm presenting you a chord bash. Maybe I'll upload a video with the actual chord bash some point. I don't want to take too much time now to do the chord bash. But maybe you can try and finish the chord bash, you know? Someone could finish the chord bash. Okay, so basically I'm saying this is a chord bash of the direction which assumes the center condition and proves the 90-degree condition. Yeah?
But then you have to do another chord bash.
Well, we'll see. I mean, I haven't tried the other direction yet. So, okay, does that make sense? So, is welcome to a synthetic solution, a complex numbers solution, and solutions for the converse and solutions which depend and don't depend on the converse. Yeah. Okay.
Was that orange?
I don't ever take lot.
Oh damn.
It's just,
Been there a long time.
no, I just don't ever take the last one. I feel like he's trying to make me happy by watching the stream at the same time to make you think you have one more viewer.
Oh, thank you.
Why so negative? David's not even here.
Oh, David's not here.
Why is there negative? Who is here?
What's a negative? Oh, thumbs down because once there was like 6 viewers and 7 thumbs.
Yeah, no, there were 4 viewers and like 10 thumbs down. It was all David, I'm pretty sure.
How was there that many accounts?
Incognito.
Yeah, so do you think like if you could, hey, do you think you would carry out that chord bash from my description of it?
I think I could.
Potentially.
If you just set the the first step, you just set like the
Yeah.
center as the radical axis on the line.
Oh, I said the center here, but you could probably set it here.
Yeah, like in the middle on the radical axis.
That's interesting. So if you set it there,
Or maybe just on the circle intersection.
yeah.
Because if you set it there, it'll make M be trivial, and D is trivial, and the line is trivial, and Q.
Okay. Yeah, maybe alternate chord bash. There's usually not that many choices to chord bash, but there's only 2 circles. Wait, when you say you chord bash everything, does that mean you've been chord bashing stuff I don't even know about?
Yes.
No, what do you mean? I don't chord bash everything. I've done the BMO.
So just from that parallelogram, it just spiraled out of control, huh? Develop a habit.
No, it wasn't parallel. It was a quadrilateral where we like chord bashed it. That was the first time, and I got it correct on my first time.
Okay, so I don't know if we have time to. I was going to show you an easier one. Maybe this is kind of an easier one.
Now we're talking about black currant or orange burst.
Wait, what?
Yes.
On the screen. And it says XY on it. Who's XY?
Sean,
Why is he XY?
because he's XY. Did the stream ended?
I think you might have solved this one last time, but I can't remember
No, it has not.
talking about this. So you have this is the earliest functions equation that's occurred in 2014. Yeah, question 3. Okay,
Is that a functional equation?
it's not a functional equation, but it has something to do with functions. So consider the functions defined for all real numbers. So this is kind of it doesn't use this notation because I think it's trying to sort of not scare people that don't know functions. And it satisfies the condition f of x plus 14 minus 14 is less than or equal to f of x. Is less than or equal to f of x plus 20 minus 20.
Is that the whole question?
Yeah, for all x. Oh, it's actually easier than this. The question is to find
Oh, okay. Yeah.
f of 8765 minus f of 4321. So I'm not going to go through the solution of this, but hopefully we can just figure it out. Yeah?
Oh, okay.
So this is like question 3. I think it's right in the middle of the exam. It should give you a feel for like makes sense.
Yeah, it's, have we done functional inequalities yet?
Don't think so, but I mean, this is like, I feel like we've done this one before, but I can't remember writing it down. What about the people in the chat? Do we know this one? Live team solve.
Number one rule is you don't have high expectations of the chat.
Yeah, which is weird because I always do.
Chat.
It's a bit chat.
Very funny. Everybody say this thing is hilarious.
All right, let's team up to try and solve this problem. So
Oh.
I'll be a good
It's
good
a function
observer.
equation. Nice.
But it's a function
Let us
in
know.
the equation.
Oh, it's an inequation.
Yeah, not
It's not. It's just some conditions. You only have to find like one value, basically 2 values.
How about you solve those values in?
Solve those values.
Wait, that was a late reaction.
Yeah, I know. Just I didn't realize how big the values were.
I said that not a minute ago. Anyways,
It's
I think
been like small values.
it's 0.
So I've been 0.
Wait, so are we trying to find the value of that thing?
Yeah. So it's not strictly a functional equation per se, but it was about functions, and it happened at question 3. I don't really think functions come earlier than question 3. Okay, so what are you saying? Sub values in?
Like first sub 0 in because it seems to be a homogeneous like condition.
F of 20 minus 20.
Especially like translation
The stream lags behind by 5 seconds.
Oh, really?
1, 2, 3.
Weeks. All right.
No, it's actually because of the echoes. It plays out loud and it's recorded, then it plays again.
Yeah, that's the thing. It's behind by 5 seconds. Yeah, yeah. It just goes to itself.
Huh?
It goes to itself.
What goes to itself?
Whatever.
No, well, that's
Mhm.
if everything is equal. then-
So actually, if this was like the AI mode, and you could maybe try to fake solve it by finding some function that satisfies this and then just plugging it in.
Yeah,
But
it
here,
goes
it's
to itself.
what goes to itself?
F of
If the
X.
identity function works.
It means the identity.
So the answer
Like, you
must
have-
be
Oh, does the identity function satisfy this?
yeah,
Yeah, it does. So the answer must be 4.
yeah. Big brain. We did.
No. This is a proof contest. If this AI mode, you'd be done, but you wouldn't know how to write the answer in the answer box.
There's only 3 digits.
Yeah.
You draw another answer box for and then write 4.
Oh, by the way, it's really funny. Like, you know, like in the AMC 8 or 10 or something in America, it's like 5% of answers are like misread errors by the computer. Like they can't tell what the person circled. 5% of all the answers.
Wait, what? That's not fair.
That it's usually the person who's really bad at circling.
Well, if you can do the AM, like if you can do math Olympiads and you can't circle stuff.
Oh, it's a maths competition. And like the average mark is like 8 out of 25 or something.
I mean,
Okay.
in year 6, I forgot to
Wait, so you're saying the identity function works?
Yeah.
Yeah.
So
It's
x
just
is
0
equal to
minus
x.
14 to 0. I
Zero
mean,
is
oh dang, no, x plus 14 minus 14 is still x, which is equal to,
No, I mean,
it's still f of x. Oh dang. Yeah, it works. F of x is still x, and then f of x plus 20 minus 20 is still f of, it's just x. We win those.
Okay, so you have a fake solve answer. Or is it find all possible values of that? But like I guess it implicitly says that, even though it's implicitly saying there's only one value.
well,
So 4, 4, 4, 4 fake solve, yeah?
and also
Also, it goes to its.
f of x plus a constant also works.
Oh, okay, the
Yeah,
constant cancels, yeah?
Yeah.
Oh. So you're saying that the linear things work? Yeah, you're saying they do,
Yeah,
right?
They do.
As long as the
Other
A
things
is positive, yeah?
Yes. That is correct.
A is positive. Where is the A? Is positive.
Wait, what do you mean A is positive?
Like if f of x was ax plus b, hold on. Does A have to be 1?
Yeah, it has to be 1, or else it doesn't work.
If x is ax plus b, A has to be 1 and B has to be, B can be anything, yeah? Why does A have to be 1? Let's see. 2.
Because if A isn't 1, then you have some very significant problems. Such as there not being one answer.
Very significant problem.
Such as there being an infinite number of answers for the final expression.
Oh yeah, but yeah, okay, but does it actually work?
Yeah,
Set
because
aside that.
A is not 1, let's say. But we just need to expand it and see.
So the AX's cancel, yeah?
Yeah.
So you have 14A minus 14 is, and the B's cancel, yeah, so is less than 0, less than 20A
Why,
minus 20.
why is it 0?
Because there's ax plus b in here, right? And I subtracted ax from everything. A minus 1.
Although because they're both either they're both positive or they're both negative.
Yeah. So that can't work, right?
They're not one.
Yeah, so I guess we've completed the AIMO portion of this question.
Yep.
If the AI moved 4 digits.
Yeah. 4 with 4 digits.
Yeah.
Okay. So this is kind of an annoying question then. What are we doing?
To say this is question 3.
F of 0 is the B part. Yeah, this is the question. I think it's very similar to this function question that once appeared on AIMO that no one got. Because no one knew about functions.
Should we do?
Well, maybe like instead of trying to find like these numbers, yeah, you could try to find like f of something smaller, yeah.
So if you substitute f equals to
Maybe you could try to find like f of 2 minus f of 1. How about that? Can you find that?
probably not.
Well, I mean, the same way we found that's 4 for 4, this should be 1, right?
Yeah.
Are people in the chat here? Maybe they can help.
Well,
And if we do this one, we can have an easy question to finish off.
I feel like you want to do something like x to x squared or something. Because I feel like you need to break the symmetry to be able to get anywhere.
Oh yeah.
Because like at the moment it's translationally identical.
Uh-huh. Could that be a good thing?
So can we prove that it's like onto or something?
Onto. Well. Mhm. What do you mean when you said it was translationally invariant?
Oh, it means like if you replace x by x plus something,
Mm-hmm.
shouldn't a constant. It shouldn't like
Oh,
change much.
doesn't change the equation, right? Yeah. And if you add a constant to f, it doesn't change the equation. So actually, one way of saying that is you can assume.
That's why I asked you for f of something minus f of something.
Yeah. So for example, you can actually assume f of 0 is equal to 0.
Yeah.
Without loss of generality.
Wait, how would you rigorously prove that?
What? Oh no, you just redefine f to be like f plus a constant, right? And this value would be the same.
Oh, okay.
And the functions will still satisfy,
Oh,
right?
yes, you do.
And then that constant just be the thing
Oh,
that
yeah,
makes
you don't need to prove it because the function doesn't matter.
the new function has f of 0 equals 0. Yeah?
So we can assume that.
Yeah.
Right, are you listening?
You end up
No. Yes, finally.
So once you have that, it just becomes like f14 is
Equal to that.
so just put the 0 in first. I would just put the 0 in first.
put what?
Like the f of 0.
This one?
Yeah.
Equals 0.
Yeah.
Oh, okay.
And then just do a bit of rearranging, separate the two equations. And it's greater than 10. Well, you already defined the constant, so you can't just slide it around again, right?
Yeah.
Because you don't know what that constant is.
Mm-hmm.
Well, no, that f of 20 minus f of 14 has to be greater.
No, it makes sense. It's 2014. Yeah, that's the year. Finally.
Yes, we solved it. Once you assume f of 0 is equals 0, you can't like slide around the function values again.
Mhm.
Do you think it might be useful for saying f of 0 equals 1 instead?
I don't think it would be any more useful than just kind of feeling like it's known.
Yeah.
That's my like gut instinct. But your idea of breaking up the inequalities isn't too bad. Have you tried that?
You can subtract inequalities as well.
Yeah. Yeah.
Wait, after you set f of 0 equals 0, you can still solve this back into the equation, right?
Uh-huh. What do you mean?
Like if you can solve f equals to negative.
Yeah, that's
14.
another good one. Yeah, I like this. So f of negative, so x is equal to 0, yeah?
Yeah.
And it's equal to negative 14. What
14.
happens?
So now 0 minus 14. 0 minus 14 minus 14. Less than f of minus 14 is less than minus 6 is less than, so f of 6 minus 1.
F of 6.
Oh, okay. So you go f of 20 greater, you know f of 20 greater than 20 and f of 14 less than 14. Well, you're subtracting inequalities to say that f of 20. No, I don't think that works. No, we might have to have a try.
Yeah, try. What are you doing?
F of 20 minus f of 14.
Oh, subtracting inequalities is not easy to do.
Oh,
If you're subtracting a bigger thing, it might not make it. It might not stay bigger anymore, right?
oh.
But you can add stuff. You can add inequalities. Hmm. Did we end up somehow learning sort of Chinese Riemannian theorem again in this situation? No.
Maybe try the opposite one, sub in minus 20.
Yes, awareness of choices. F of -6, -14. Less than f of -20.
Might be useful to if you can like do something like
X is equal to -20. Loss. What is -20? I mean, all of those just work because there are 3 numbers in the thing.
Say what?
All of those just work because the plus, it doesn't really matter what the X is. Because whatever the X is, it's still +14 -14 and +20 -20. They just cancel anyway.
What do you mean?
So if it's a 1-to-1 function, it really doesn't matter what X is. Because the +14 and -14 and the +20 and the -20, like,
No, not for one-to-one function. No, this is not. they don't cancel, yeah.
oh yeah.
no, but like when you apply a function, they're most likely going to cancel. Because they're like 1-to-1.
Oh.
What are you doing?
Alright, I have a suggestion from the chat. If you just keep subbing in x for the lower bound and upper bound,
Oh, come on.
you get f of 140 minus 140 less than or equal to f of 0 less than or equal to f of wait, listen up. This is kind of like some kind of lowest common multiple business, yes? That's why I was saying Chinese remaining theorem. someone in the chat is claiming this. Yes, I like it when people in the chat actually say stuff. It's good.
Instead of
This is new to Monday class. So it actually depends a lot on when if Sean's here or not. If Sean's here, then the chat goes dead.
What?
Okay, so we have
So we should just kick Sean. True.
okay, so CJ is saying that if you keep subbing in X for the lower bound and upper bound, you get. Yeah, can we confirm this? Do we get this? We get f of 140 minus 140 is less than or equal to f of 0 less than or equal to f of 140 minus 140.
wait, how would you get?
How do we get this?
Wait, are they the same? Why can't you put the same thing?
Huh?
F of 140 minus 140 less than or equal to 1. F of 140 minus 140.
So that means that they're equal, right?
Equal to F0. What? Okay.
What is if f of 0 was equal to 0, right? And that would make f of 140 equal to 140, yeah? Yeah? So if this works indefinitely, it would solve the problem.
Oh, you mean like oh, okay. So you can sub in any value.
Okay, so why is it 140? Well, 140 is the LCM of 20 and 14, yeah? Does that make sense?
Mm-hmm.
So I think what happened is, like, I think what he's done yeah, I think this is a good idea. So look, you have like f of x plus 20, yeah? So this is 140, yeah. So maybe this is like f of 120 plus 20 minus 20, yeah? Is greater than or equal to f of 120, yeah? Right?
It's greater or equal to F of 134.
Well, let's just do the 20s, yeah? Because this is always getting down. So you can do f of 120 minus 20, yeah? Are you watching this cat ball?
Yours.
Yeah?
Yeah.
And then this is bigger than or equal to f of 100, right?
Just that.
Yeah?
Yeah.
And then you can minus 20 from everything again, yeah?
And then put it back in and minus it
Yeah.
again and put it back in.
So f of 100 minus 20 is ultimately less than f 140 minus 60, yeah? Which is greater than f of 80, yeah?
Okay.
Does that make sense?
But how are you allowed to like minus 20 from inside this one?
Yeah, because it's just inequality.
That's what happens. Yeah, see, look,
Like inside the function.
we're
How
not.
do you know it's going to like?
But that's what this condition is.
Oh yeah, we're just using the condition. That's approximately
Oh, yeah.
We're using the condition that's
Huh.
approximately. And that gives us a infinite descent.
Yeah, so this is
Yeah,
a really
yeah,
this is
yeah,
a really
it
good
makes sense.
idea.
Well done, CJ.
Hmm?
Rather often.
Mm-hmm.
Infinity descents.
Yeah. So this gets that 140 minus 140 is equal to Okay. Is equal to f of 0, basically. Okay, so how do we keep going with this then?
So when you have it, it makes sense. Because the problem is 8765 isn't the multiple of 20 nor 14.
So what is it a multiple of? It's got remainder of 5. And it's got remainder 11. The other one's got remainder 1. So wait. So you're claiming the problem before you even claim the claim. So you're basically saying oh, Sidra's also got another claim. Yeah, but you're basically saying that f of any multiple of 14 or 20 is the identity, yeah? That's basically what we're saying. And CJ is saying that f of x is equal to f of x plus 140 minus 140. Uh-huh. Oh yeah, so you don't actually put 140 there, you put x plus 140. And that same thing would happen, right?
Do you think it's more intuitive to go from 0 up or something?
Yeah. So this has gone from an inequality to an equality. This is a big progress.
Wait, isn't that for any multiple of 20?
Yeah, so I think I can prove what he's claiming. So basically the same argument, right? So look at the argument. So let's look at the argument. It basically you have the f of so you let x be x plus 120, right? Yeah. That makes sense? Come on, you're drifting away. And then this is f of x plus 120, right? And now you have the same argument where you keep the x in there. Right? So then you do f of x plus 100 plus 20, right? Minus 20 is less than or equal to f of x plus 140 minus 40, yeah?
Oh, so you keep the x.
You keep the x, yeah? This is algebra, yeah? The x is your friend, remember?
You alright, bro?
No, it's fine.
The floor is not the
Yeah, probably not.
Not the what?
not the best.
place to lie.
Yeah.
Retracted.
Your x is your friend. You don't want to get rid of him.
Yeah, so then this is now f of x plus 100, right?
Yeah.
Okay. So if you keep continuing this, then you get f of x is less than f of x plus 140 minus 140, yeah?
And the reason why you choose the lowest common denominator is because you can go from the other side as well.
Yeah,
You can go from 14 as well.
yeah, exactly. So then you get f of x is equal. You get
14, so f of x is equal to f of 140 minus 140.
yeah.
See our first equality sum in a while.
Yeah. So basically, if you can assume f of 0 equals
0.
0, yeah, which we can, then f of any multiple of 140, yeah. So f of a multiple of 140,
But can't we set f equal to f0 equal to whatever that will make the remainder be answer easy.
yeah, and I think this would make it easy. What do you think?
Well, I mean, like for 8765 mod 40. Mod 140.
No, I don't think it would change the difference because whatever it is, it cancels when you subtract anyway, yeah.
So that you can get to the function values.
Oh no, you won't be able to get to the function values
Oh.
with it. Like you can't, you can't cheat the system. Yeah, there has to be actual deductions. You can't just create like sometimes, yeah, like it looks like that, but there has to be actually something. Yeah, but here it's like once you set f of 0 equals 0, then you get f of, like, for example, 140
Equals 1.
is equal to 140, right? And then f of any multiple of 140 is equal to that same multiple of 140, yeah? Yeah, so the point is now we know what f is for every multiple of 140, yeah? But these are not multiple of 140 apart, yeah? But, I mean, this is such huge information, it could be that you could find out every value of x, you know? Like, essentially, you could actually be solving, you're actually solving that f is the identity.
You just keep minusing until you get to the end. Well
Not
done.
quite, not quite. Don't rush.
But basically, if you know, so for example, what are these numbers mod 140? What's 8765 mod 140?
Something.
Something.
8765 mod 140.
8765 mod 140. And I want
It's
to
like
know
85 mod 140 or something.
I also know 4321 mod 140.
Times 4. Let's do 4, 3, 2, 1 first.
It's
That's
like 85 or
121.
something.
It's 121, 140. Why are you using a calculator now?
It's like 85 mod 40.
It's 121.
What?
21. So 4, 3, 2, 1.
I'm saying 8765 is 85 mod 40.
85 mod 140.
Yeah. Oh yeah, mod 140.
What's your reasoning?
Hmm?
What's your reasoning?
Oh, I just did it.
What did you do?
Divide.
Divide.
Long division, whatever.
No,
Long
short.
division.
Short division too. No, 140, right? It's 140 times 6 is 840.
60.
140 times 6 is 840.
Yeah,
so
that's-
it's
that's-
minus 840.
So
So you
that's
get 365.
365.
And then minus 140, minus 140, you get 85.
Okay. See, now I understand what you're saying. 365.
Yeah.
Minus 140, minus 140, you get 85, yeah?
Yeah.
What about this?
He did that one.
So CJ is saying that it's
It's
121.
121. Yeah,
Is that
that's
right?
what he said. Yeah,
So then the 280.
because it's just 140 times 3, so
5,
420, and then it's just 121. That's literally.
Oh, okay, I see what you're saying. 121. Hmm. Scott,
I am dying.
can you like?
Yeah, go back. I'll probably sit up again.
Wait, why is he coughing though?
Huh? I don't know. Ah, I'm dying
You spend the time sniffing the floor.
now.
Just control, okay? I don't need to be shut down.
What? This place doesn't need to be shut quarantined for 14 days.
Yeah. Or 20 days.
Oh dang. Very.
Or
funny.
121 days.
Oh
That's
no.
really funny.
Or something 140. 140.
Okay.
Why is this problem so hard suddenly?
Well, I mean, you have 4 hours to do this. Well, you have at least an hour to do this.
Well, don't you have 5 questions?
Yeah, but the first 2 are not really.
Are you sure about that?
Well, you'll see eventually. This is the kind of. But usually people say that when they're not making progress. You're saying that at the moment that we've made the biggest progress.
I think we should do an experiment. Like, does sniffing the floor really make you cough profusely? F of x equals f of x plus any multiple of 14 or any multiple of 20. Is that something?
Huh? Yeah.
Aren't you just solving the Diophantine equation?
Kinda, yeah.
But isn't any multiple of 14 also equal to 14? Wait, is that?
Yeah, so maybe is it not a multiple of yeah, you guys are doing good. You shouldn't give up.
If 0 equals 0, I have 140 here. 140 here. 140 here.
Yeah, so CJ was saying if you get from 121, you can get back down to 1
1.
with the 20s, yeah?
But can't you just stop in x equals to 120?
Yeah, so this is a really key observation, yeah? Look at this.
Huh?
So,
Like 121.
Yeah, so both of these, this is actually Chinese remainder theorem in a sense. See, this is 1 mod 20, right?
Yeah.
And this is 1 mod 14.
Yeah.
Right? So you can meet them both at 1, I think. Yeah.
Well, how would you get an F? Oh, okay. If you initially assume that it's not F x was 1 instead. X
Yeah,
is
instead
1.
of 0, you have 1, right?
Yeah.
Can you not, like, as you said, can you not just like get the 120 down to a 1 by minus
No, you
That's what he does. Yeah, that's what
and
he
get the
Yeah, you
85 down to a 1 by minus 14?
Yeah, that's what you said, right? That's what he said as well. Well, I mean, I'm like, there's no point asking me, right? I'm just doing what you're telling
Yeah,
me to
you
do.
have to do. We have to actually have
Yeah.
to do it.
Do it. Ow.
And like, yeah, the funny thing is, I don't have the solution in my mind. So this is all your work, right?
Okay.
And so the progress is actually the progress you're making.
It's not some kind of guided adventure that doesn't actually mean anything.
Yeah. So you have f of 1 is less than or equal to f of 21 minus 20, right?
Yeah.
Which is less than or equal to f of 41 minus 40, yeah? On the other hand, it's greater than or equal to
Why am I dying?
f of
Very good questions.
15 minus 14, yeah?
Hmm.
Which is, I don't know if this is super abusive notation, I'm sorry. F of 29 minus 28. Yeah? F of 85 minus 84, yeah?
It's less than f of
F of 1.
less than 85.
Yeah. No, very good.
So we add an
Mhm.
so we can meet them both at the number required.
Mhm. Right, so now they're different numbers. What does this mean?
Wait, no, we're supposed to meet them at 4321.
4, 3, 2, 1.
Does that work?
Yeah, so I mean, the thing is, if we can do f of 121 minus f of 85, we can do the big number as well. Okay, we have another comment. Could you meet it at something else but mod 14 or 121 and mod 20 for 85? Ah. So you're doing mod 20 for 85. You get 5. And mod 14 for 121, you get minus 19, which is also 5. Oh, so these numbers that special?
These numbers are very cool.
Yeah, they're not just any old numbers.
Are you serious? Oh, he's telling Kavan not to die. Yeah, don't die.
Yeah, at least if you're gonna die, don't bring us with you.
Yeah, so I think this is what CJ is saying. So if you bring it down to 5, f of 5,
Yeah.
I suggest you drink some water.
so you're saying 121 minus 56 is 65, and 85 minus 20 is 65. Hmm. It's 14 times 8. 14 times. Wait, you said something else here. So what did you say? F of 121. So he's saying that 121 minus 65, 121 minus 85 minus 20 is 65, yeah?
What are you like doing?
So I feel like he stopped somewhere in the middle here.
Yeah, it's like I feel like there's some kind of not clicking.
F of, yeah, I think he's basically solved it. So F of, so 65 is 85 minus 20, right? But it's also 121 minus 56, yeah? So I feel like you can go all the way down to 5. So it's greater than f of 121 minus 56. I need some space to write some stuff here. Erase that part now. Okay. They say f of 85 plus 36 is equal to f of 121. Okay. Let's do this. Yeah, so if you look at this equation he's saying, yeah, then f of 121 is less than or equal to 36 plus f of 85, yeah?
Did you just sub 65 in for the finish?
So basically the fact that 85 minus 20 is equal to 65 subs x equals 65 here, yeah?
Yeah.
And then the fact that 121 minus 56 is also equal to 65 is like doing this one like 4 times, yeah?
Oh, okay.
Okay. Now 121 he's saying is less than or equal to f of 85 plus 20 plus 36, yeah?
Oh, so it's like pretty much unrelated to functions now, basically just a remainder theorem question.
Yeah.
Chinese remainder theorem.
Basically nothing. Oh.
But we also had f of 85 plus 36 is less than 121. From here, yeah? Oh, is this right, by the way? Is this the right number of 14s? Did I make a mistake here? I feel like it shouldn't be 30. Is it 36? It should be 36, I guess. It should be 36. Yeah, the other 36 came from here, I think, yeah? I think this one is slightly mistaken. This one should be 126. That doesn't make sense. 16. Wait a minute. So what's 121 mod 14?
121 mod 14 is just.
Oh, it's -5, is it? Yeah, so this line doesn't help. It's -5.
So we still up to 56, 121.
Yeah, so this one's right, yeah?
Yeah. That's just the basic one. And the following one, that one I think it's also good.
Yeah, can you see this one, right?
Yes.
It's f of 121 is greater than or equal to 36, yeah? Yeah? Does that make sense? It's these two equations here.
Oh.
So it's not actually important what these are because they're just helping you get you, they're just going through it. Yeah?
Oh, okay.
So that means they're equal, yeah?
So how do you get the coefficients, like the constants to match?
Which constant?
Do they just work like the minus stuff?
This. Oh, we haven't even used that yet, but we could just let f of 0 be 0 if we want.
Oh, I mean like the constant minus 120 minus 84 minus 56 minus 20.
Which one?
The full constant.
This one.
No, I mean, how do you show that top line?
Top line.
The very top.
That.
Yeah.
How do I show the first one or the second one? By the way, if you combine them together, it's equal sign,
Yeah.
right?
Okay, man, see how I show like 121 is less than, yeah. How do you show it's greater?
The greater than comes from this one, right?
Oh, okay, that makes sense now. The less than comes from that one?
Yeah.
Yeah.
Okay, good.
Hmm. Yeah, still works. Just do it again for. Yeah. One 65.
Wait, can't you just chain it upward from here now on?
Huh?
Can't you just like just start adding multiples of 140 to both?
Yeah, exactly. So I mean, this is basically done. Yeah.
Yeah. Like,
So you have that f of 121. So 121 is the smaller number, unfortunately. So it's f of 85 minus f of 121, right?
equals to minus 36.
This is minus 36.
So and then you just
Then you just need to add in the multiples, right?
140.
Yeah. So the point is f of 85 is equal to some multiple of 140 plus that, yeah? And I think CJ said it's what the
Big
multiple
brain
is.
time.
Wow.
CJ said it's big brain time.
No such thing as a big brain time.
Yes, it is.
Because like
Yeah, so basically it's how many multiples, right? You just add that many multiples of 140 here, yeah? And you subtract that many multiples of
It's
140
big
here,
brain time.
what?
yeah?
So you add them.
Because f of 85 is equal to f of x 85 plus 140 minus 140, right?
Oh yeah, because like, yeah. So you just add that and then use the reverse. Use the x plus 140 back
Yeah.
into the x and then.
So basically, whatever multiple you need to add, you just actually directly add that multiple outside the bracket.
Yeah.
Yeah.
Because for example, f85 you can say that's f200 and
Yeah, exactly. Minus 140 L,
40K.
yeah. And that'll equal to
My
Right.
dad,
40
I presume.
K minus L minus 36. Yeah.
Yeah.
So the K is just the quotient when you divide that by 140, and L is the other quotient. Yeah.
It's your dad or mom.
Okay.
Okay. So can we quickly verify that's 444, or
Yeah.
we don't have enough time?
We can.
So what is the quotient? How many multiples?
The quotient
So
is.
you said last time it was 40, right? 4.
Yeah. Oh.
You said it was 40? No,
No, it's
30.
much
You
less.
said 30, 30,
30, and that's it.
30, yeah? So L is 30, yeah?
Yeah.
Wait,
L is
And so-
30.
Wait, how's L30?
Is that what you said?
140 times 30
Yes.
is the remainder 121. And
And
for the other
yeah.
one,
Yeah, the L. The
it
other one.
was like 620. No, 62. Yeah, 62.
62?
Yeah.
Okay, so then it's 32 times 140 minus 36, yeah?
Yeah.
Is that right? Hopefully that's right.
I'll just quickly check that.
Yeah.
That should be right. 'Cause that's
4200.
yeah, that's 320 times 320 128. 448 minus 4,480 minus 36 4444. Yeah.
Is that right?
Yeah.
Okay, excellent. Yeah, and we didn't even have to assume f of 0 is 0.
No,
right?
because
even,
like
even though you could, yeah.
you could, but like
It
because
helps you.
it's translational symmetry.
Yeah. Okay, awesome. All right, nice, CJ. So I gotta see some of these guys out. I'll be right back. Okay.
Okay, hopefully we don't die.
Bye bye. See you in the next life.